Welcome in, everyone. I forgot to get music started, so let's just do that now. Shit, wait, my mic is working, right? Okay, good. I realized that I forgot to put my mic on. Like, I was about to start the stream. I didn't realize until after I restarted the stream. Let's just do that song and that radio. All right, good enough for me. Okay, so I'm glad my Discord notification did work. I just started using StreamerBot for that. Okay, YouTube's live. Okay, good. All right, I guess we can get into it. No DMs from last time. Meet in the middle of US and Germany for the fight? Yeah. Hope you guys are good swimmers. Give me your 10 streak. Ah. You know, it's just, I'm sorry to break it to you. You're just not dedicated enough, I guess, Fetchery. Oh wait, no. Twitch like stole your streak, didn't they? You know, does StreamerBot have a way to Twitch? Do they have streaks integrated? Chat message, cheer, hype chat, whispers. I guess that's what you said. Yeah, that's what you said at least. Community goal. I don't know why I'm doing this on stream, but like, present viewers, shadow receives, stream update. I just want to see if it, like, can I do anything with the viewer streaks when people share it? Kind of fun. I don't see an option for it though. Oh well. Maybe I'll look into it more later. Okay. I need to make a Discord post. I think my stream schedule is going to be like, I potentially have stuff planned for like Sunday and Monday too. I'm like your math crush. I always do embarrassing mistakes in front of you. Yeah, I'm sure you're just like constantly blushing too. I'm really glad that I found that thread that did basically the exact same problem, because I would not have noticed that thing with the ease if I didn't see that thread. Oh, that's when they say graph, they mean like graph theory. Okay, never mind. Dude, where the heck are all the unanswered math questions? We're gonna have to go over to the Discord again. Had a statistic exam today and went pretty well. Oh, was that what you were working on for the MLE thing? I would forget what it, like mean likelihood estimate, but whatever. Maximum likelihood, yeah. Oh, nice. Well, glad it went well. I did take calculus-based stats, but I don't remember ever doing that, to be honest. A two-dimensional? Oh, I guess like a sub n minus 1, a sub n minus 2. Oh, stack exchange? I'm sure stack exchange got it. Really? Wait, you can't divide both sides by 2. That's illegal. How would you do that the right way? See, arcsin doesn't really have identities. Can you draw a triangle with this? Or wait. This is such a weird identity. Is this even true? Let's look at that first, because it's the classic, can you prove this trig identity that's not true? That's happened to me way too many times. Hey, Stookie. Oh, that's a really good exact result, Wolfram. Thank you for calculating that for me. Whoa. It makes kind of a cool graph. Wait, so these are definitely not equal. Wait. They give an interval. Pi over 2 to pi? Pi over 2 to pi. Maybe they are... this is probably a better task for Desmos. Trig missed a mistake, only find out it's wrong. Yeah, I mean, well, I've gotten stuck. Like how do you prove this trig identity? And then you plug into Wolfram Alpha and it says that it's false. And it's like, oh, well, that's how... Or it's just like not even possible to prove. Cosine x over 2, parentheses. It's kind of a... It's arcsin, but it repeats itself. That's kind of cool. And it's sometimes reflected. What's the other side? Arcsine 1 minus 2 sine x. Arcsine 1 minus 2 sine x plus pi over 2. Oh, they are equal over this one interval. I never remember how you do. Is it like that? Okay. I don't really know why Desmos doesn't tell you on the screen how you do this stuff, but as far as I can tell, they don't actually like tell you. But okay, so this identity is true over this interval. It's not true over different intervals, which feels kind of scary to me. Like my instinct is to draw a right triangle for maybe that arcsin. Maybe use a double angle, like... We do have the different... And how to, like, you go from a 2 out front to a pi over 2. Actually, this identity goes the wrong way, doesn't it? So you plug in x over 2 for theta. Yeah, this will give you x over 4s. So you can do this identity and do like the square root of that. That feels wrong though. So maybe you do draw a right triangle, maybe. But I really, like, I don't know how drawing a right triangle works when you have, like, the plus pi over 2 or the 2 times. That's what scares me about trying to draw a right triangle. I think I'm just gonna move on from this one because I feel like I could go around in circles on that one and not get to an actual answer. Oh, well, this one I can definitely answer though. If we need to find x over 2, given that x equals 1/2. Oh wait. Okay, yeah. X over 2 means x divided by 2. So if you take x equals 1/2, 12, 1/2, you get 1/2 divided by 2, which means you multiply by the reciprocal. So it's 1/2 times 1/2 equals 1/4. It's a little interpretation thing, I guess. Actually, they were here and here is the same exact thing. I should actually add that in. Same thing. Both expressions evaluate to 1/4. Okay. I guess we're going over to the Discord. All right, we're here. That one someone's working on. Oh god, we got geometry. Oh wait. I was just messing around with my scene for this before I went live and I forgot the Discord needs to be moved over too. An ABC rectangle. There's at least there. Hey Cloud, how's it going? There's an AC diagonal that is ABC's bisector. That doesn't compute, but okay. Crosses the diagonal in point M. I don't know what's happening with this problem. I'm going to move on. I don't know what that command's supposed to be, but oh, this is a complex number I. Okay. Huh. This seems kind of fun. Summing up powers. I don't know how you would do this. If you put it into like exponential form, does that give you anything nice? Actually, put it into trig, or actually exponential form. The angle's always the same. Can you factor out the radius? Well, the radius is going to be increasing though, or it's going to be changing at least. Well, the angle could be changing too. I don't know. Oh, good, my timer is working for the announcements. Maybe it's just binomial theorem. I don't really know. I don't know how, it seems like a fun problem. I don't know how you do it though. Two simplex pachinko machines. Yeah, so I was thinking about that, but you saw the sum involved, and I don't really know how you deal with that sum. Like I was trying to think of this, like trying to get it, like maybe the trig form would let you factor something out, but you still get angles being multiplied, and I guess it's always multiples of 45, but you can try to make some statement about it always be the same value, but different signs. So yeah, I don't know. I feel like I have half an idea of how you do that one, but I'm not really good enough complex numbers to figure it out unless it's like spelled out for me, I guess. Oh, I didn't think about working on both sides of the equation. Equal to square root 31 squared plus 1 times CAS arctan 1 over 31. Well, Now, I think that problem would be pretty simple if it was 1 plus I to the power of n, but this is a sum 1 plus I to the j from j equals 1 to n. Yeah, so I'm still not sure that's easy, at least because I still don't know how you deal with that summation, but that's probably the idea. You know, just maybe get like two different equations, one for the angle, one for the one for the radius. What's happening here? This person is being... Okay, but let's see if we can understand what the question is. This first one, g of x equals x minus 1 minus 3. I don't feel like this person is trying to get you to do their homework for them. I'm not getting that sense yet. See, it looks like an absolute value function that's it has not been scaled. It's just the scale of the graph is weird, where a horizontal one is more than a vertical one. Okay. So I'd say it's absolute value of x. Absolute value of x minus 1 outside the bar is minus 3. So I think they have the right idea. Nearly. This is nearly right. But g of x equals x minus 1 minus 3 is a straight line. Makes a straight line, not the V shape that you see on the graph. Do you know what absolute value of x looks like when graphed? See, it's been like 10 minutes since they replied last. It might be a minute. Let's see if they get back to me though. Oops. Given y equals arc cosine x, -1 is less than x is less than 1. Okay. And 0 is less than y is less than pi. I think that's the normal definition of arc cosine. Yeah, as far as I remember. Express arcsine of x in terms of y. Really? So do you take the cosine of each side, and then you take the arcsine? That's okay. I think I know how to do this. It's kind of a weird question, but I assume part B is gonna give some interesting answer here. This feels like a question that Zach would ask. That's very like leading. Oh wait, before I switch over, okay, this person actually got back to me. So before I switch over to that, let's work with this person a bit more. Graph y equals, see if that works. Let's get a Decimus link for this person. We're not looking at that problem. -3, since the vertical translation goes down. Take absolute value of x, translate it to the right by 1, and translate down by 3. You had the right idea of the line. And then if this person, if that answers this person's question, we'll move on to this kind of interesting one. That's Robert Downey Jr.? I think so. Dude, we have to help out Robert Downey Jr. with this math problem. All right, so this person is taking me back to me, so let's switch over to this problem now. Now I saw that bright spot on my whiteboard, so I guess I'm just going to cover it up with the problem and try not to write on that section of the whiteboard. I'm still figuring out how I'm going to make this thing work exactly, so bear with me. I should get some, like, I should zoom the camera out so there's space on the wall above it so I'm not blocking my board. But it's kind of hard to get an angle like that, to be honest, because that means I'm zooming out in every direction. Anyway. So what do we have? We have y equals arc cosine x. Am I writing far down enough? Oh god, that's not an x at all. I'm not. Ugh. We have -1 is less than x is less than. I should check that. Less than or equal to 0 is less than y is less than or equal to pi. Okay, good. Okay. So we have to express arcsine of x in terms of y. So I'd start by doing whatever we have to do to get arcsine of x. And so first let's isolate x that's stuck inside the arc cosine. So let's take the cosine of each side. And we get cosine of y is equal to x. And now, as funny as it feels, I guess we take the arcsine of each side so we can get to arcsine x now. So we get arcsine of cosine of y is equal to arcsine x. So I guess that would be an answer there, or you could even draw a right triangle, I believe, and maybe simplify this. Like, how would that look? If that's our angle, sine is opposite over hypotenuse. So opposite is cosine y, hypotenuse is 1. Is that sine squared? Or just sine? I think that's just sine y. Yeah, it is. By Pythagorean theorem and Pythagorean identity, 1 minus cosine squared y is equal to that side, and that is sine squared, and root of sine squared is just sine. Okay, so that's good enough for me. I guess that means that sine of y is equal to arcsine x. I don't know, it might be more convenient to have it in that form. I'm not really sure yet, but we just do have that fact. Oh wait, we have... I don't have this backwards, do I? Oh wait, it's we have no, I do have that. I have that backwards. If you had cosine of arcsine, what I said would work. We still have this step here is right. I just did a bad simplification. I don't think arcsine of cosine simplifies. As far as I can tell, I don't know. Maybe there's, I'm kind of curious if there is now, but let's see if we can do the part B here. Evaluate arc cosine x plus arc sine x, or hence evaluate arc cosine plus arc sine. So arc cosine x plus arc sine x, well, we know arc cosine x is y. We know arc sine x is arc sine cosine y? That doesn't really make like, what's special about this? Is there simplification that we need here? I think we need to consult Google. Or maybe Wolfram. Because I definitely seen the reverse situation where you have like cosine of an inverse trig function. You can simplify that. I can't say I've had this situation that I can recall though. What does Wolfram Alpha think of arcsine cosine x? So does it simplify that? Oh, it seems like that should simplify. Hey, Budza. F prime of f of x. Oh. We can take a look at it. The best place to go would be my Discord. And you put a screenshot there. So Wolfram, it doesn't... And just make a thread in the math homework help forum. And if you can't find it, just let me know and I'll make a thread for you and add you in it. So this update seems like it's going to be just a line, we've restricted our y's to be 0 to pi, and it looks like that's from 0 to pi there. How? So there is a way to simplify this. I'm just maybe not drawing the triangle right. Just Google this. That's the reverse. That's okay. Oh. All right, perfect. So I'm going to put a pin in this problem and look at Budza's problem. Ooh. All right, so let's, hopefully it's legible on stream. The graph of a function f of x is shown below. Sketch f prime of x. Oh, a graph may not be exactly to scale. It should be positive, negative, 0, and increasing and decreasing in the appropriate places. You should pay attention to relative scale. Interesting. All right. Just reading it again and making sure that I have the right idea here. All right, so I think I'm actually going to do this one in Paint because I don't want to have to recreate this entire graph on my whiteboard. So let me get a thing of Paint open. All right. So here we've been given f of x, the actual function itself, and we want to sketch f prime x. So maybe I'll even do it on the same graph here, just so we can, and I'll do it maybe like, I'll do like this part of the graph, and I'll leave the other part to you to at least try. So this first part is actually, it's giving me I'm like trying to think of okay, so I was trying to think of how to express this. So I think I'm starting from like, I'm going to start from this point here just 'cause it's like a clean like endpoint. So Astro, thank you. Cutest math streamer around. I appreciate you. The 7 months, dude. Thank you so much. Even played one of my favorite alerts. Okay, yeah, I kind of like being zoomed in a bit more. Okay, so Budza, this is actually giving me a little bit of trouble too at first, but I figured out what to do now. So you can see like going from this endpoint and going along the curve of the graph, it starts out very steep, it kind of flattens out, and then it goes very steep again. So what we would expect to see is at its steepest, we have a very high y value for the derivative. And so we don't have to be exact here, but we want to start with a very high y value for the derivative, hit 0 where it flattens out exactly, yes. It's like right around there where it flattens out is where I'd expect to see a 0 point. So let's start like, I'm kind of just choosing a height to start from. We're going to start high and decrease. And I'm trying to engineer it so that I get to 0 right at that flattened out point. Hey, Brian. And now it goes, oh wait. I just flipped this. So, you know, I was going from right to left, but that's bad. The slope of our tangent lines is a negative. So I was saying the right thing, but with the we're gonna be negative in having this kind of same behavior. That was bad of me to mess that up, but yeah, so slopes of tangent lines are negative. It's consecutively decreasing as we go from left to right. That's sometimes I get flipped in my head, but so yeah, we touch 0 here. Slope is negative. But then on the other side of this, our slopes are still negative. So we're going to touch 0, but I think we're going to come right back up here and go off to infinity like that. If the graph instead like curved around here and we started to get positive slopes, then we would cross over the 0 point. But in a situation like this, I think we just touch it and then bounce back up. All right, that's good because I was looking at like, oh, the function is positive here, so our slope should be positive, but no, you care about the slope of the tangent line. All right, so it sounds like you're probably on board with this first part that I've drawn here. Tell me if you're not, please. Looking now at kind of the second part, like I'm splitting things up based on the corners here. Yes. And so wherever there's a curve, wherever there's like a cusp, or wherever there's like a corner, as I call them, I'm drawing these kind of basically asymptotes because it's not differentiable there. We can't define the derivative at that point. It's the derivative that makes sense, but the derivative is undefined at those like cusps or corners or whatever you want to call them. So you can see in this little section here, we have, this is just a line, and it's a positive slope, but it's a pretty shallow slope. So I might draw just a straight line. We should be careful with our dots and circles here, like somewhere around there. It doesn't actually matter all that much. And then open circle here, because the derivative isn't defined on that cusp. Open circles like, yes, exactly, Budza. And Brian, I guess you're right. It doesn't actually flatten out. I was thinking, yeah, I was thinking like it might depend on how you're zoomed in to this, but it doesn't really flatten out, I guess. Second derivative. Yeah. All right. I think that's a valid point, Brian. Thank you for that. So just like mentally in my head, I was just making it a cubic function, but it could be, it doesn't have to be a cubic function. So yeah, I guess we don't quite hit 0 with our derivative there. What the glazed donut is this? It's confusing. That's what it is. Yes, but so perfect. So I'll just draw arbitrarily higher up, like there. Gosh, that isn't, yeah. It doesn't actually flatten out. I wonder if like arctan would be a more fitting thing to call this than a cubic function. I don't know if arctan has the same property where it completely flattens out or not, though. It's not important. Okay, so, and I said I was going to leave this for you, but since you've been like vocal in saying what things are before, or like since you've been so vocal, let's like work through the rest of this. Oh yeah, sure, Brian. Well, what would you say is happening with maybe this piece right here? Why do we have this horizontal dot? Oh, for that asymptote. Okay. And I'm working out for myself too. similar with a negative slope, so under the x-axis going to negative infinity with the same vertical asymptote. I agree with that, yeah. So we start out, I mean, I'm just kind of arbitrarily putting a dot here. Something that's definitely negative, and our slope is increasing, and it's going to have the same exact vertical asymptote, so that's perfect. And I think we're going to have a similar idea over here with a little bit of a catch. So what do you think for this right side? Oh yeah, Pen, I'm not even showing the question. This is the graph of a function f of x, and we have to sketch the derivative. And I messed up on this a few times, so it's, I'm glad that I have chat here. So maybe I'll give you a little hint. Maybe about the x-axis. Okay, yes, perfect. Because the slope is always increasing. It's always, or the slope is always positive. It's not always increasing, but the slope is always positive. So I'd say we're definitely always above the x-axis. 3-watt streak. Oh, thank you. And so you can see the function starts out as like nearly vertical, super high slopes. But it gradually kind of flattens out, and it nearly goes like, you know, completely horizontal. It never quite will. And so for that reason, previous horizontal asymptote. Like the one from the horizontal asymptote that's here definitely has a lot to do with the behavior here. But I don't know what you mean by previous horizontal asymptote. Yeah, the horizontal asymptote is everywhere, but like this part of the function here is unrelated, I would say. Oh, okay, so you are saying that. Okay. So yeah, I'd say looking close to the vertical asymptote here, the slope is super high. And then looking here away from the vertical asymptote, the slope is super low. And it's by nearly flattening out, I mean, it's going to be getting closer and closer to 0. Oh, hey, cheers. Thanks for the 6 bits. So for our f prime x, I would say it starts very high because the slopes are very high over here. And it's going to ignore the horizontal asymptote in a way, and it's going to get very close to 0. So it has its own different horizontal asymptote basically at y equals 0, rather than using the same horizontal asymptotes. That's actually kind of a neat little trick. Like vertical asymptotes are always the same, but horizontal asymptotes, I think for derivatives, they'll almost always change to be 0. Yeah. You see? Okay, awesome. So yeah, I hope that makes sense for this question. If you have any more, very first point, this one here, I believe no, because the derivative at an endpoint, even if it's included, isn't defined. Because I think you could draw a whole bunch of different tangent lines there if you cared to. I believe that's like the rationale. You could, like, you know, guess, but I think for the sake of a derivative, you wouldn't define it there. Let me Google that just to be absolutely certain. Now you may, because that's a good question. But it's the derivative defined at endpoints. I'm like 99% sure that it doesn't. This homeworkstudy.com site agrees with me. In Penn Center, okay, yeah, usually say if you leave it open. Yeah, maybe there's some definitions where you can allow for it, but I believe your limit has to exist from both ends in normal in your normal like calculus class. Slip and slide factoring? I don't think if I do, I haven't heard it by that term. But yeah, so Can we define that endpoints with derivative is a bit more fussy? Yeah, I think so, Pen. Or at least that'll make sense. Thanks. Yeah, no problem, buds. If you have more, please keep them coming. And if that's it, then thank you for the question. For quadratics? No, I haven't heard that term before. I think I'm going to put my mug away. 1 second. All right, so let's close out of this paint window. Let's see if... Okay, so there's still this person who I think I can figure this out. Robert Downey Jr. Okay, so I ended up with having to simplify what I have on the board, or what basically arcsin of a cosine, which I haven't encountered before. So I've encountered cosine of arcsin. And I was looking into how you can simplify arcsin of cosine. So it looks like you can do it. So you take this fact and you do a change of variables. That's really clever. um, Especially optimize the volume of a box with no top. I think a 12 by 12 sheet of metal. Cut 4 R by R squares from the corners. Ooh, not the cutting squares of the corners thing. I've seen the volume of a box with no top, but not the cutting squares part. Yeah, sure. Just let me maybe get to the bottom of this trig question, just because I don't want to erase my work that I have so far, and then I'll take a look at that. Because this trig question is kind of interesting to me too. Let me there. Maybe a follow-up question? Okay. Okay, so let's erase this last step. I don't really like it. So what that second change third was saying to do is to look at what arcsin of sine of x equals to x. How do they define it again? Because arcsin is a little bit weird. Equals x plus 2k pi? No, minus. Ugh. Or it's pi minus x plus 2k pi. and it depends on the interval. So the first one is minus pi over 2 to pi over 2. The second one is pi over 2 to 3 pi over 2. Okay. Now, if we take y equals to x minus pi, I mean, maybe it's a bad form to use y. Maybe let's do like a, because I just don't want to confuse with like that y in the problem. If we took, let's just call it z equals x minus pi over 2, we get something kind of neat. Arcsin sine of x minus pi over 2. I mean, even I don't know. Just take x minus pi over 2. More of the story. I feel like I'm expressing it wrong with that. Minus 2k pi. Pi minus x minus pi over 2. Pi. 2 pi k. I can't write things right, I guess. That it's also going to change our intervals. That gets subtracted by pi over 2. Minus pi over 2 minus pi over 2 is minus pi, comma 0. This goes from now 0 to pi. And I think we're going to take that one since we know that sine of x minus pi over 2 is also cosine. So arcsine of cosine of something. Actually, which one do we want? Oh yeah, from 0 to pi. Okay. So I think we want that second line there. And we can even split out the minus sign a bit more and work with it. Pi over 2, or pi minus pi over 2 is plus 2 minus pi k. So, I don't know. I don't know if I feel like confident enough. What am I writing? I'm hoping that I get something that looks right, and I'll feel confident enough to get back to this person with this. So the ultimate goal was to evaluate. Oh gosh, arc cosine plus arc sine x. Arc cosine x plus arc sine x. Arc cosine x was just arc cosine x. Plus arc sine x. Okay, so arc cosine x we know is equal to y. And arc sine x is equal to arc sine of cosine of y. And arc sine of cosine of y, well, I guess we can write that first. And arc sine of arc cosine of y by this is y minus, or y plus minus y plus pi over 2 minus 2 pi k. So we just get, the y's cancel and we get pi over 2. And what should it be our value for k? Is it k going to be 0 here? We can verify this graphically. I assume we're going to want k equals 0. Okay. Oh my god. Of course it's equal to pi over 2. Because we're talking about a 90-degree angle, right? Yeah, doy, this is pi. Oh my god, I don't know. I should know about what arcsin x plus arccos x actually means. Because isn't one talking about one angle of a right triangle, and the other one's talking about the other angle of a right triangle? And if you eliminate, right, and the angles of the triangle have to add up to 180, and one of the angles is right, the other two have to add up to 90. Okay. So yeah, k equals 0 instead of okay. Yeah. Okay. I feel like I can express my thing with the right triangle better too, but so I didn't say what they got stuck on. Yeah, I'm kind of glad that I saw that one through because I didn't think it'd be that simple. All right, Robert Downey Jr. Help is on the way. What's it get? Were you at least able to do A? Okay, and so let me take a screenshot of the board so I still have my work. And then we'll switch over to looking at Brian's little for fun problem. And we'll switch back into to looking at that person's problem as they reply back. If they do, they might have left, which is okay. Just give me 1 second. Okay, I got my screenshot. This person hasn't replied back, so you're saying to optimize the volume of a box with no top by taking a 12 by 12 sheet of metal and cutting 4 R by R squares from the corners. Okay. And so I assume the actual shape of the metal is not related. That's just going to affect how we calculate the area. So let's erase this. It's going to take me just 10 years, you know, don't worry about it. Oh, this freaking eraser, dude. I should just spray this thing down every time, I guess. I don't want to have to do it, but like, okay. So let me make sure we want to draw about there. Is that good with the chat? Okay, good. We're not blocking anything. The original metal is a square, and the 12 provides a particular answer. Okay. So let's start by making a drawing. I guess we'll draw it with the squares already cut out. Got a weird looking plus sign, basically. R. So we have this situation. 12. Okay, I think I've represented it accurately here. And we want to make a box, the box with the highest volume. Okay, box with the highest volume and no top. Okay, so let's talk about the area of this. The area of that is 12 squared minus 4r squared, right? Because we have 4r by r squares that are removed. The volume of our box is we have to work out the length, width, and height, I guess. The surface area of the box is going to be 2 length times width plus 2. Oh, no. I need to actually define my measurements here. Length, width, height. So it's only 1 times. I'm defining that to be the top, I guess. Me pointing that probably doesn't actually help. Let's do, wait, we have a length and a width on the bottom, and then around the sides we have 4 width. No, we have width times height and 2 length times height. That's our surface area. Just check in chat, make sure I'm not missing anything. Okay. It's annoying me that I'm saying that's 12 squared. Just say 144 times 4r squared. Okay. So I'm more familiar with these with 2 variables. Here we have 3 variables. We can eliminate one of the variables, and then we have a 2 variable optimization. Oh yeah, that's how you do it. So the surface area of the box totals up to 144r squared. That's what 144 minus 4r squared. So we want to solve this for you fold the 4 flaps in your picture to form the box. Oh, I was taking it as, okay, that is important. So what r by r squares do you cut to make the highest volume? That's a very different problem. Interesting. Okay. Or that's a problem than I had interpreted. So thank you for beeping at me. So that means our r is going to become like our height. And it's going to be a relationship between, I think we can safely take length equal to width. And then r is going to be like length minus something, right? Yes and yes again? Okay. So let's get rid of this for a minute. Oh, who's that? A7RL1, thank you for the follow. I appreciate it. We're just working on this problem from BC or in chat just for fun. Okay, so we're going to take length equals width, r equals h, and then there should be some relationship here with 12 minus 2 times r. So maybe not r equals h. Well, it kind of is, though. Or r equals h equals 12 minus 2... Or no. No. I'm thinking about it backwards. That's why I'm getting confused. R, take 12, subtract out the middle, and divide by 2. So it's, we can call it length, equals L minus 12 over 2. I don't know why the middles of my 2's are getting cut off, but... hey, A7. How's it going? If you have a homework question, please feel free to, like, let me know. Okay. So... the volume of the box is L, I'm just doing everything with L instead of W, L squared times L minus 12 over 2. And I guess we just optimize this. Because it's one variable, so we can just derive it, can't we? We don't even need to worry about the surface area of the box. And I'll check chat again in a second to see if I'm doing something horribly wrong. L equals 12 minus 2r. Oh, A7, yes. I have two things that I would recommend to you. The first one that I like the most is Paul's online notes. So it's not very proofy, which I think is appealing to someone who's learning calculus for the first time, but this goes over basically the entire calculus curriculum, at least as I learned it. Like, there's nothing that I learned as a normal part of calculus class that was not here in one of these 3 sections. So I'd highly recommend this site. And it goes through, as you asked, from 0 to, you know, basically the end of what people would consider a calculus class. And if you want something that's a bit more like fun, just for like a mental break, I would also recommend, like, it's fun, but it's also very educational, Black Pen Red Pen's YouTube channel. He does a lot of very fun, like, challenge problems, and also explains a lot of concepts and things like that. So those are the 2 things that I'd, like, recommend to you the most. Yeah, we'll welcome in. Okay. You definitely want to have good pre-calc. I think it's equal to 12 minus 2r. Oh, I did mess something up. I should have said r equals 12 minus L over 2. And then I had the same statement as you have, which I feel like we'd have the same... Oh yeah, we don't care about L, we care about R. Hey, Jed. Okay. So I made a mistake. That should be 12 minus L. Yeah, 12 minus 2r. And R, 12 minus L over 2? Doesn't... That's just R equals R. That's redundant. R is just height, though. R, yeah. R is just height. Okay, I see what you're saying now, Brian. I was pursuing the wrong path entirely. Okay. So the volume of the box is that squared times R. And we want to find the optimal value of r here. I started with A7, yes. He does have some things that are a bit more like systematic that build on each other, but you're right. I wouldn't call his channel complete calculus course. I'd call it a for fun break if you want to reinforce certain concepts. Inged, yeah, it is geometry, but it's also calculus, so it's not quite your favorite thing, but the problem is basically you have a 12 by 12 square, you cut out the corners, like each of the corners, squares at the corners that are r by r. If you fold up those flaps, what's the optimal box that you can make with no top? So we worked out what the dimensions of this box are, and we have to now derive it and optimize it. So I guess we'll do a product rule here. I think that's the easier way to solve this derivative. Times 2 minus 2 equals 0. Okay. Let's do some grouping so we can avoid having to factor. Well, I guess we'll stop to factor. I don't think we're avoiding it. Is this less fact? I know it's actually no, this saves us work. Oh, hell yeah. Okay, because r is equal to 2 over 12 or 4. I assume one of these isn't quite right though. No, that's 1/4. And 2 over 12 is 1/6. I assume we're going to have to check if those are minima or maxima. And if they're both maxima, then we take whichever one has the higher original volume. I just make sure I didn't make an algebra mistake here or a derivative mistake. That part rule is good. Derive that, the 2 comes out, the r stays there. 12 minus 2r, 10 minus 2. Group out the 12 minus 2r. Get a... Oh, no. I made an oopsie. This isn't 1, it's 12 minus 2r still. Minus 4r, 0, right? That seems better. 12 minus 2r, 12 minus 6r. We still get 2 positive values for r, which is weird. That is what it is, though, I guess. Okay. Let's do our v double prime. I guess we're going to do a product rule that. So deriving that, you get minus 2. Deriving that, you get minus 6. Not equal 0. We do not, that's not equal to 0. We plug in our values for r, and if it's positive, you're concave up, so you get a minimum. So let's take v double prime of, I guess, 1/6. That, ugh, dude, why can't this be easier? 12 minus 1 is 11, times negative 2 is negative 22. That is 12 minus a third. Let's multiply the 6 in. It's 72 minus 12 times a, no, yeah, 12 times a 6 is 2. Oh my god, I can't do mental math. 2? I said plus. That becomes 12. 12 times a 6 is 2. Okay. The derivative calculation. Yeah, so the derivative, that's the function I set up. I was too lazy to factor everything out, so I did a product rule with r and 12 minus 2r squared. So that is from deriving the r, and then this one is from deriving 12 minus 2r squared. And I did the same trick with that to get v double prime. So this doesn't actually matter what it is. I just know it's less than 0. So this is a maximum. I bet v double prime 1/2 is going to be maximum too. 12 minus 3 is 9. 9 times 2 is negative 18. 12 minus 1 is 11. 11 times negative 6 is negative 66 is less than 0. So we get 2 maxima. Okay. So then, if we want to decide which one is the more maximum, we have to plug it into the original, I guess. Ugh, okay, so v box of 1/6. I chose the harder one first. 12 minus 1/3 is 35 over 3. Oh man, who wants to do that math? That is 7 times 5. Oh, we didn't get a simplification, bro. Hey, hoo-hoo, how's it going? Oh wait. Did I make a mistake here? 12 minus 2r equals 0 gives r equals 6. Oh, wait. Oh my god, I did it backwards. You're right, Brian. I flipped it. Check your batteries. No worries, Jet. Dang it. All right. You're right, Brian. I can't do I can't do single variable algebra. I shouldn't have erased v double prime though. Ugh, okay. I'm giving myself more work because it's fun. I was trying to save time. I was trying to save work, and then I ended up costing myself more work. So there's that for you. So yeah, r equals 2, r equals 6. Okay. We still have to do our same thing, I guess. Minus 2, 12 minus 6r, minus 6, 12 minus 2. Okay. V double prime of 2. Can we just solve this to be positive or negative? That's 0. Okay, I was expecting to get zeros in here and I didn't, so I was getting a little bit confused. That one becomes 0. That one is a negative 6 times a positive number. Minus 48. Yeah. V double prime of 6. That one becomes 0. That one becomes a positive number. Aha! 12 minus 36 is minus 24. Minus 24 times minus 2 is positive 48. Oh, hey, so they even have the same concavity. So I would say r equals 6 is our optimal box volume for this. Ah, okay. 2 plus 4 equals 8. Yep, that's me. Oh yeah, we can, that's a save. I can do that. Oh, you got him? All right, thank you. Check work. Oh no. When r equals 6. Oh wait. I just gave Brian a save for something else earlier. Why is he so only at 1? Where was it? Oh, was Nubot asleep when he did that save? Wait, I didn't even see my message where I hit save. Oh no, but Enigmabot never replied. Dang, alright. Enigmabot's on the fritz, I guess. It's probably my box and you put it in space. Oh! Yeah, r equals 6 doesn't really make sense, does it? Oh, yeah! Yeah, okay, so I did the math, I did the arithmetic right, but r equals 6 makes no sense. It means you don't have anything at all. So we want something very close, we want to get as close to 6 as we possibly can? That seems weird. that that is a cute face, hoo hoo. I gotta give it to you. Donda's linear boxes. Yeah. It's a two-dimensional box. What do you mean? So we definitely wouldn't take r equals 2 because that's going to be a minimum. So I think you take r equals like 5.99999, right? Or 6.0001. That's not very... It's usually we're storing pencils, maybe, or you can store like a line of pencils, I guess, with a box like this. The answer is 2? 2 is a minimum, though. Let's, Oh, wait, is the function... Did I mess up a sign? Or do I forget what second derivative means? Oh my god, I forgot what second... I literally did it right the first time. I made the mistake, I erased my work, and then I did it wrong the second time, doing the exact same thing. I interpreted the second derivative wrong. Yeah. Okay, r equals 2 is right. Broccolo, thank you for the follow. Okay, I saw you in Dex chat. I'm glad to have you around. I was talking about what I have in Wolfram. This is for different problems, actually, like, pretty fun. Figuring out what arcsin of x plus arccosine of x is. It's pi over 2. It should have been obvious, but it wasn't to me. Nothing much with me, Broccolo. We're just working on a little problem from BC Aura. Wow, this... How long? I've been streaming for an hour and a half? It didn't even feel like it. Dude, today's been fun. I need to get more music going. Let's try that. Yeah, well, what's the follow-up, I guess? 212 minus 4 squared. 128. Okay. Oh, and Jet already plugged in too. And just to see, the person who's doing this arccos plus arcsin problem hasn't gone back to me yet. Just to make sure we're keeping half an eye on that. In a way, Broccolo, I took a screenshot of my work. I had it written out on the board. I will just put it in this like math chat thing just so like we can look at the image easily. This is how I worked it out. You basically you express arcs. You start with y equals arc cosine of x. You figure out what arc sine of x is in terms of y. And then you're forced to evaluate arcsine of cosine of y, and that's like I had to Google it to figure this out. But you have to use arcsine of sine of x equals x minus 2k pi or this thing. But there's a much more intuitive way, which is you draw a right triangle and you figure out that arcsine of x and arccosine of x are complementary angles. They add to 90, and so their sum is just 90 or pi over 2. This is the actual math that I did. Yeah, so it's super complicated to show like algebraically, but just with the right triangles, it's super simple. And I didn't realize that until after I already worked all this out. It's a really neat problem, to be honest. Okay, so the follow-up question. Oh, sorry, before I read that. Pablo Molina over on YouTube. I need the vectors of any bridge. How do I do it? Are you talking about like the force that acts on a bridge in vectors? I'm not sure what you mean by that, Pablo. Yeah, exactly, Procolo. I had that exact same issue, and once I got like just pi over 2, because I figured out like k equals 0, I was like, wait, that's way too simple. Why is it just pi over 2? Why isn't it a function? It's like, oh, that's why. So yeah, Pablo, I would need some more information, and it's probably not going to be in my like expertise, I guess, because I'm not too good with like physics or engineering. So PCOR is saying, so the follow-up question is, can we use only algebra to show r equals 2 as the answer without using any calculus? Verify the answer if someone gave it to you. Algebraically, can you say that r equals 2 is the answer? So, I mean, that's a good question, Broccolo. I would say that I wouldn't call myself an expert in anything. My background is I have a bachelor's in applied math and a minor in computer science. So it depends on how you want to define expert, but I wouldn't call myself an expert on anything. But what I like the most is calculus and differential equations. I think differential equations is my favorite, but I'm pretty rusty on it. And I can sometimes help out some people with like some linear algebra questions, but I'm also pretty rusty on that. I'll do anything that's like calculus and below, though. After that, I can try to help, but my knowledge gets a little like patchy. So Brian, algebraically, I gotta think. Knowing that r equals 2 is the answer, we have to do some graphing and vertical translation stuff, is my guess. So if we were to graph that, we have a cubic with zeros at 2 and 6. 1, 2, 3, 4, 5, 6. So it's a cubic with positive leading coefficient. So it's going to look something like that. It bounces at 6 because 6 is degree 2. So I think if we want to show that there's a maximum at, wait. I'm bad at math. The zeros are at 0 and 6. Because I was looking at these zeros, but it's those zeros. 1, 2, 3, 4, 5, 6. So it passes through 0 and then it bounces at 6. I should have made the maximum a bit more clear at being 2. So what I'd say is that we want to shift this function vertically down by whatever this height is, so that way it equals 0. And then we show the function around it is always negative. That's my kind of only thought here to do this algebraically. Even then, it's not necessarily, I wouldn't call it a proof, but 3, 4, 5, 6. And like just show like we have a positive end over there, but if we can show it's like, you know, f of x is less than 0. Oh my god, not close brackets. Minus infinity to 2, union 2, 6, and f of x equals 0 at x equals 2, I think that's basically showing it's a maximum locally. I don't know if that's good enough, but that's kind of my thought. You have a solution too? Oh yeah, please post it. Zach, thank you so much. Congratulations on the 200 followers. Robbie, hey. Jabloni, I see you over on YouTube. Just give me 1 second. I'm not sure that's where that problem is going to go. We can try it though. Amazon, hey, welcome in, everyone. So what is this camera angle? A work in progress. That's what it is. SBQ, I made it so I can now like stand up at the board and do all my math, but I'm still not really happy with how everything is laid out, but it's good enough for now. Taylor, hey, welcome back. So I'm trying to figure out like a better angle for the camera and better ways to do all this stuff, but for now, you guys just get to deal with this. So I missed a few things in chat just before you guys came in, but just to introduce myself, because we do have so many people here. I'm Don. And I do math, if that wasn't obvious. I do math on Tuesdays, Thursdays, and Saturdays. I do video games sometimes after math, and pretty much always on Wednesdays and Fridays. Yeah, no, this has been what I wanted to do for the stream nearly since I've started. It's just been difficult to actually set this up logistically, and it's still not even close to perfect, but yeah. This is how I have been envisioning the stream to... It's close to what I've been envisioning the stream to be for a long time. Let me scroll up in chat and see what I missed. We do have a potential... We have a surface area integral that Jabloni put in the YouTube chat, and I'm still trying to decipher, but let me... So yeah, Brian, I'd be happy to look at your solution. And then Broccolo, this is a mega random question, so I don't know if you know anything about this, but you try to understand the solution of the Poisson equation, separation of variables to spherical harmonics. Ooh. I don't remember. I feel like I learned about that once. I'll copy paste it in chat for if anyone does happen to know it offhand. I might have learned about this once, but I think I've forgotten everything, so I'm sorry about that. I'm ahead of the curve in its differentiable. I don't know, but like, yeah, I'm trying to figure out like lighting, so I don't like having that super bright spot on the top of my whiteboard, and I have a tripod, but it's kind of crappy, so I'm still trying to figure out like how to angle my camera the best, so I can still switch back and forth between it. Jabloni, you're from Poland. Oh, nice. Well, welcome in. And so yeah, for anyone who's new, I dual stream to YouTube and Twitch, so if you hear me talking to someone who's not in Twitch chat, that's why. All right, so you're talking about the surface area. I'll copy paste it over into Twitch chat too. Oh, Sharky, can I help you with your calc homework? Sure. Please, you can post your question right there in chat, or if it's easier to post a screenshot, you can put it in my Discord. And, okay, before BPCOR is saying R equals 2 plus T, this is saying what the difference from 2 should T be. Find the area of the box in terms of T. Find T equals 0 maximizes. Oh, you basically make it into a parabola that has a known like maximum without having to do too much calculus? Oh, you're making bread, Taylor? That's awesome. I love making bread. Good luck with it. Oh, dude, I made this bread just yesterday, and I tried this cheese called Humboldt Fog. That's a line of mold in the middle, which scared me a little bit, but it was really delicious. Yeah, I had a sourdough starter for a long time, but I just made this yesterday. It's just like a French bread. Okay, sorry, I'm getting kind of distracted, but yeah, I love making bread. Okay, so I'm sorry, Jabloni, I promise you I'll look at that problem now. Baguette. The French people come out of the woodworks. So we determine the surface area when -6 is less than y is less than 9, and y is less than, is that x squared plus 10? For every math nerd I knew that made bread, you have 2 nickels. Yeah. So yeah, I won't keep you, but I'd love to hear like what bread you're gonna make. But if you have to go make it, please dip out. Don't let me delay you. So wait, y equals, oh wait, -x squared plus 10. So this is a parabola, but what did I just do? Oh my god. Oh no, okay, we're good. Just sandwich bread? Oh, nice. All right. I'll see you, Taylor. Oh, when you hold right click, how do you scroll on this? Oh my god. It's just a parabola. Oh wait, this isn't a multivariable problem. I'm making it multivariable and it's not. Wait, so the surface area, actually, I'm still a bit confused, I guess, Jabloni. Is this like a surface area of revolution problem? You don't make baguette, you buy them? All right, who? Do you prefer them from a bakery or store-bought? Baguettes you made are pitiful? Hey, that's 3 math people who like baking, though. Interesting, BC Aura. Bakery? Okay, good. At least you, well, you said you don't like the bakery croissants. You like bacon? Jabloni, are you still here? So I'm trying to figure out, the question. Jabloni? Are you Jabloni? So yeah, I think I understand that part. I mean, we can say 6 less than y less than 9. Oops, that's not it. That's it. So, Jabloni, are you rotating the shape around and you have to get the surface area of that? Sharky, you can post your question in the math homework help thing. Just make a new post and you can put it there. Choquette? I'm not sure what that is, but it sounds good. Calculate the surface area. Oh no, you're good, Penn Center. Oh no, I was talking about baguettes and who was French, so that like brought her out of the woodworks. We don't have a French problem though. Thank you though. Oh shoot, I don't know why I just closed. I didn't need it. So Jabloni, is it like anything like this where it's 3-dimensional? Je sais, je sais. So that means I see. I see. Because the surface area, it could mean this 3-dimensional thing, so I'm worried about there being a translation issue. Or it could mean arc length. And I don't want to do the wrong thing for you. So is it more like this? I doubt it's arc length, I guess. Or is it more like this? I know? Oh, okay. Just integrals. These both involve integration, though. That's where I'm getting confused. First one? Okay. We can definitely do this. Let me look at the formula, though. It just says, I think. Oh, okay. So, are we rotating? Ooh. It's I know? Okay. Okay, Jabloni, I guess another question. Are we rotating around the x-axis or the y-axis? Who is the resident Frenchie? Because I guess there's, I don't know. Because you could rotate it around the x-axis like that, or like you could rotate it in one direction, or you could rotate it like in the other. It's really hard to explain in words, I guess. But there's two different types of rotations that we could do here, and we'll get different answers depending. Is there a way that I can show it? Like, I don't think Desmos will do solids of revolution. About the excess? Okay, thank you. All right, I think I finally know everything that I need to know then. Thank you for bearing with me on that. Okay, so let me go over to the board here and work this out. And Sharky, I'll get to your problem after this, but the other person asked first, so if you do have to go, I'll get back to you in Discord. Okay. So we have y, oops, not equals. We have y is less than minus x squared plus 10 for 6 is less than y is less than 9. Just make sure I'm copying down the problem right. We want to rotate this about the x-axis. So our formula for rotation about the x-axis is the integral of 2 pi, I already forgot it, y. Two pi y, which is minus x squared plus 10, times the square root of 1 plus dy by dx squared dx. And our integral is going from 6 to 9. Oh, wait. Our integral is going, yeah, Dr. Gold. It's been a minute, so I'm just trying to make sure I don't mess this up too horribly. Wait, okay, this is actually a little bit... With the arc length term? Yeah, because I'm trying to figure out if we want things in terms of y, or so we want to use this formula here. But the x-axis, you just want to use dz. I just do it as like a multiple integral. Sharky, hey, thank you for the follow. I need to see an example problem, I guess. This is nearly the same thing. Not quite, but more or less. Can we do the... Okay, so we can do the integral in terms of x. But how do we chop off the top? Do we have to break this up into a couple of different ones? Like... So we're trying to rotate this around the x-axis. Oh yeah, and like it's defined in terms of y's, but I want to integrate in terms of x. And so how do we capture that in terms of x? It seems like we would need to do some subtraction of multiple integrals here. Yeah, or just doing things in terms of y, I guess. But then if we do it in terms of y, aren't we switching how we're rotating? I guess that's what I'm getting confused on. Yeah. That's making it a lot harder. Yeah, Jabon, it's still a hard one. To rotate around the x-axis, it's not easy to get everything in terms of x here. So Jabon, the problem we're trying to figure out are the bounds of the integral, because they're given to us in terms of y, but we need to integrate in terms of x to rotate around the x-axis into 3 parts. That would make sense. Like, is it going to be -2 to 0? Okay, yeah. Or, oh wait, yeah, that wouldn't make sense. I guess it's like -2 to -1, 1 to 2, and then -1 to 1, and subtract off the middle? Yeah. I think that makes sense. I hope that'll get us what we want. -1 to 1 is just flat. Well... Oh, wait. Yeah, we don't need to worry about the parabola. No, we should just do a constant like y equals x. Or no, y equals 10. 9. Yeah, no, I was thinking about the parabola, but no, we just do the parabola for this part. We do y equals 9 for this part. And then, okay. All right, that makes sense. I guess we'd have to make sure we don't get the middle part there. Oh god, how do we eliminate the middle part? Or how do we like eliminate everything below? We have to subtract out y equals 6 from -2 to 2. I think we need 4 integrals. I guess we can do 1 and double it to do the parabola part at least. Actually, no, I don't think we need to worry about maybe below y equals 6. Yeah, we're trying to get a donut, basically. So it will be outer surface area. All right. So, gosh. What we're saying is we have a parabola like that. You want, I don't know, that part of the surface area is making me a little weirded out, but we're gonna break the integral up into 3 parts, I guess. We're gonna do an integral for that part, integral for that part, and an integral for like 1, 2, 3 parts. This part is a parabola, that part's a parabola. This part's a constant function. Y equals 9. Y equals minus x squared plus 10. Minus x squared plus 10. Can we just use a cylinder for that middle part, I guess? The surface area of the cylinder? I guess we could. Oh, or equal to? It doesn't actually make a difference for the problem, but it's good to know. It doesn't make a difference for the math that we're about to do, but it's at least be technically right. Okay, so the surface area of revolution integral will get us kind of like the outer and not the inner, I think. So I guess we can figure out the antiderivative in general. Well, I mean, we can figure out for the parabola. I don't think it. Let's figure out the antiderivative for the parabola, and then we'll do the bounds after. Because we're gonna need to do 2 separate things here. I guess we could do only one side and multiply it by 2. That's probably so we can do it just all in one. All right, so I'm gonna set up 2 times the integral from -2, we said, to -1. Just making sure I don't do anything catastrophically stupid. Okay. I'll bring the 2 pi outside as well. Actually, no, to make it more clear, for the first step, we'll do 2 times 2 pi minus x squared plus 10 root 1 plus the derivative of that is minus 2x squared. Or minus 2x, and then we square dx. Okay. That's not an easy integral either. Oh, God. We need to split this up into 2 different terms. I'm supposed to write sines. I think we're going to need a sine sub. We're not there yet. I don't know what to do about that one. I guess it's going to be a sine sub as well. It's just going to be harder. All right, looks like you agree with me so far, Dr. Gold. Thank you for working this problem through with me. So I think for both we do the same sub here, u equals sine x. Sorry, sine u equals x. Which means dx is cosine u du. All right, plugging in. -2 to -1. Sine squared u root. How to deal with the 4? Oh, I need a coefficient. That's how I deal with it. 1/2. Because the 1/2 gets squared. Yeah. Which means we get a quarter out there. Okay. Plus 10 root 1 plus cosine squared u du. Uh, times a half cosine u du. Okay. Oh wait, this is tangent? Oh god. Hey Ben. Yeah. Oh, sine is for minus. Yeah, you're right. Ugh. Okay. So it's not a sine sub, it's a tangent sub. Tan u equals x, secant squared u du is dx. Okay. So 1/2 still. Minus 1/4. Tan squared u plus tan squared u. It's 10 root 1 plus tan squared u. 1/2 secant squared u. Oh my god. Disgusting. -2 to -1. That's a secant, so we get -1/8 tan squared u secant cubed u. Might need to rewrite that in some way at some point. That's secant times secant squared. 1/2 5 secant cubed. All right. So your brain is fresh. Oh, good. Oh, thank you, Henrik. DI method time, Baracolo. Do we need it? I don't think we do integration, but I mean, obviously I've done a bunch of things wrong so far, but oh my god, secant cubed is so annoying, isn't it? It is integration by parts. You might be right. I don't know if it's DI though. I might be. I think I'm gonna Wolfram this, dude. This is this is a long integral. Yeah, because this is like you can. Oh. Sharky, thank you so much for the sub. I really appreciate that. It's an exercise left to the reader, yeah. So Jabloni, this one it's getting really difficult. Let's just at least get an answer for Wolfram, and the actual mechanics of the integral are a little bit too much for me to do right now. This isn't gonna be the entire answer, but let's just see what this part of it is. So we had a 2, -2 to -1. 2 pi square root 1 plus 4x squared dx. Oh my god. Arcsin? Okay, I'm glad I tapped out with this. I feel like this is, I don't know. That seems like a really complicated answer. I mean, you could have gone something with Ellen's or something as well if it's arcsin, but like... I wonder if we were supposed to do around the y-axis or something, because that would have made it 20 times easier. Are you still here, Jabloni? It's from your exam for math? Oh, I'm sorry I had to do this one. This is ridiculous. You have to do that for an exam? Yeah, this integral seems way too difficult. I gotta think it is supposed to rotate around the y-axis or something. Nobody's that sick as a teacher. Yeah, because it's either that or your teacher hates you. And sorry, for people on Twitch who don't see it, Jabloni's over on YouTube, so if you're trying to follow in the chat, that's why it might be hard to do it. Yeah, so it's even the entire answer, Jabloni. This is only part of the answer. You also have the inside part from -1 to 1, which you can just use a cylinder for that, granted, and then you also need to do the inside radius as well, I think. I do OBS multi RTMP. It's completely free. It's really easy. The other instance of OBS thing is possible too, but it's this plugin. There. It's hard for me to find, so that's the actual like place where you can download if you go like all the way down, but it's super easy. It's like it is a little bit janky to stream on YouTube too, but it's not so bad that I can't like live with it. And also you get like at least 2 saves there. If EnigmaBot is actually gonna work. Oh, okay. It looks like EnigmaBot woke back up. And then I think I owe Brian a save too. It didn't go through on one of those last ones. All right, so yeah, I'm sorry, Jabloni, but I feel like I don't know what to tell you about this question. It just seems way too hard. Like you can do it, it's just a lot of work. Where did Sharky post their question? Oh, I see it. Question 215. The real numbers have a least upper bound. Talking about from Zach's real analysis. We were talking about how if there is an upper bound, there must be a least upper bound. But in general, as far as I know, the real numbers don't have an upper bound, or an upper bound in general, much less a least upper bound. But I'm not sure. Yeah, I'm so sorry, Jabloni, but I think either there's a typo and you're supposed to rotate that around the y-axis, or the question is just unreasonable to give to a student on a test with limited time. So yeah, I'm sorry I don't have a better answer for you, but it's just like it took me a long time to work out this integral by hand, and I feel bad that I'm keeping Sharky waiting too. But yeah, doing that on the x-axis is really hard. The y-axis I don't think would be that bad at all. But the x-axis is not easy. So they're up in order complement. Yeah, I'm not sure, Broccolo. All right, so let me 215. So this one, use the following exercise given y equals f of u. F of u. Sorry, it always makes me laugh when I see f of u, like f u. U equals g of x. Find dy by dx using Leibniz notation for the chain rule. Dy dx equals dy du, du dx. Okay. So okay. I was just refreshing myself on this in my head, but they gave you the formula for it in the little prompt here. So let's work through how we would actually apply that formula. They don't make you find that for yourself, thankfully. Because if they did, I would have had to like be like, I'm not sure. Or, ooh, I think this is how it is, but this makes it a little easier for me to remember. So 215, let's not cut that off. Put, gonna scale it down a bit, I guess. Okay. Just keep covering up that bright spot until I figure out an actual situation for my lighting. Okay. So let me look back at the question again. Subaru. Do you know if you did it correct? Oh yeah, sure. So we have y equals 6u cubed. And u is 7x minus 4. So with chain rule, if you want dy by dx, the kind of issue they run into is that y is only given to in terms of u, but u is in terms of x. So with chain rule, you get dy by du times du dx. So we want to figure out what dy by dx is, and that has two components, dy du and du dx. So let's figure out dy du first. Ugh. Just deriving that in terms of u, just like a normal Calc 1 problem. So it's 18u squared, just doing the power rule there. Du dx, we do that, which is just 7. And then just the formula, we multiply them together. So dy dx is, oh, well, 18u squared times 7. We should give it in terms of x, though, I think. I think that if we want dy by dx, we should probably use our little fact here to get in terms of x. 18 times 7. What's 18 times 5? Is it 90? Yeah, it's 90 plus 18, plus 36. 90 plus 36 is 126. And then u squared is 7x minus 4 squared. I guess I call that my answer. Does that match with what you got though, Sharky? Oh, awesome. Glad to hear it. An invisible whiteboard stick-on surface? Invisible whiteboard? I don't know what you mean by that, Brian. Thanks, Sharky. I'll see you around. Okay. The whiteboard moved? Yeah, I'm still trying to figure out what exactly I'm going to do with it. This person just tapped out. This is only my second stream with it, so I'm like, I think I could do way better with it. I'm just a little confused. It's not easy to set this stuff up, at least for me. I don't see any other questions from chat, so I'm just gonna look for questions out on this Discord. What's happening here? The new lighting is immaculate though? Oh. Honestly, I didn't change the lighting at all. I still have this ugly bright spot at the top of my board, but the last time I streamed, I was just sitting in the dark because I didn't like that bright spot so much, but I eventually broke down and just did it and like turned it on. Oh, you might not have been there for that part where I broke down and turned it on. But I want to get actual like ring lights or something. Oh, maybe, yeah. No, this looks complicated. Oh gosh. Taylor's theorem with the vector functions. I haven't done that. I don't know if I want to do that. Yeah, my multivariable calculus is strong enough. I do love multivariable calc. I just don't remember it well enough. Because the camera's closer? Oh yeah, maybe. That's an interesting way to do it. I've never done a complex limit though, so I wouldn't feel comfortable commenting. Coordinate proof? Oh, I don't know coordinate geometry. Quality seems higher that way? Oh, good. Yeah, I'm thinking that I want to like maybe try and zoom out the camera so there's dead space up above. It's a little bit hard to actually get it, but like I don't like the Twitch chat is blocking part of the whiteboard. I'm trying to figure out what I do with it instead. Man, I don't like how the camera's like leaning forward now. My tripod is kind of crappy. It looked way different when I bought the tripod on Amazon. But the tripod has a tendency to kind of like lean, and I don't like it. I don't know how to easily like fix it though, besides just buying a nicer tripod. I should probably honestly just do that because this is it's a little meh. Probably buys you more than the average viewer. That might be true. I do worry about it a lot. Ooh, we got polar coordinates. Really? The magnitude and direction relative to the horizontal. What? Is it the relative to the horizontal that makes this problem hard? Why isn't just the given information that the magnitude is 100 and the direction is, I guess 10 degrees? Oh, I guess we know it should be 180 somehow in 66.31. I guess it is the relative to the horizontal part. How do you go from 10 degrees to 66 degrees? radar station. If the polar coordinates of the rocket from the radar station are r theta, quick question. Oh yeah, I mean, this is just a random question on the math Discord, so whenever you post it, I'll just switch to yours. I don't really get this one, to be honest. I feel like I have half an idea, because I guess you have to translate it from polar coordinates relative to the radar station to polar coordinates relative to the horizontal, but I don't get where the derivative comes into play with that, I guess. With the second derivative. It looks like a bear. Woohoo. It's kind of an interesting problem. I don't really know how you do it, though. Oh, God. Using a compass? I'm okay. L roots. JL? That makes no sense to me. Jabloni on YouTube. Point A equals -7, 1 is the vertex of an isosceles triangle ABC, in which AC equals BC. Okay. Both coordinates of vertex C are negative numbers. The equation of the inscribed circle in triangle ABC is given. What's the equation of the circle, Jabloni? Need to translate it? All right, Spetri sounds good. I don't have a question I'm working on right now. Oh, sorry, Spetri was saying something about translating too. So, I guess whoever when Spetri translates it, he just said it was a quick question, so I'll do that one, but oh wait. The plus is the mouth? I thought the plus was the nose and the line was the mouth. I guess it can be either. Oh, I don't know how good ChatGPT is at translating. No? Oh, I'm sorry, I was doing it wrong. Hoo hoo. See, Javon, thanks for your question. What's the equation of the circle? I think we're gonna need that. 6 unique drinks. Okay, and for Spetri's question. 6 unique drinks are split between 2 people, and each person gets 3 drinks. Uh, you don't have the solution? Okay. So if the order of the drinks, is this 6, choose 3, I guess? Yeah, 3 drinks is kind of a lot, Spectre. You might want to calm down. What I'm thinking is, it's basically, the 2 people thing kind of just throws you off. Just focus on one person, think about the 3 drinks that one person gets, and that automatically says what drinks the other person gets. Non-alcoholic drinks? Ah, okay. And I think that just makes this 6 choose 3, because whatever 3 drinks the first person gets determines the other 3 drinks the other person will get. So I think the answer is 20. So Jaboni, I need the equation of this circle. Like there's a part of the question that I'm not seeing, I think. It's like, what is the circle? Yeah, so that's what I think. I'm not that strong with those types of problems, but I'm pretty sure it's 6 choose 3. Because if you choose 3 drinks for one person, the other person only has one possible. Oh wait, do you have to multiply it by 2? No, I don't think you do. Those are really tricky. There might be some distinction that I'm missing. S squared plus y squared equals 10? Okay. Okay, I think that's all the information that we need now then. Hey, hard luck. I didn't know that. Oh, that's circumscribed. I want inscribed. I'm trying to see if there's some kind of theorem that we can use for an inscribed circle. Wait. Oh yeah, okay. Why 6 over 3 and not 6 times 5 times 4? Oh, it's 6 choose 3, not necessarily 6 divided by 3. But it's 6 times 5 times 4 is if the order is important, I think. And 6 choose 3 is if the order is not important. Yes. Because 6 choose 3 eliminates the duplicates if, like, you don't care what order the drinks are served in, you just care what 3 drinks are chosen. So 6 times 5 times 4 cares about the order the drinks are served in. Yeah, if they weren't unique, that just means that you would, I think reduce the total or something like that? I'm not sure. But I believe 6 times 5 times 4 would be for permutation, which does care about order. So I wonder if we're going to need, like, this formula, or... Maybe we should just draw this and try and work it out. So... I'm going to cut paste this over to Twitch chat, too, just so... it's easy to see in Twitch chat. So I don't know exactly how we're going to do this problem, Jabloni, but I'm just going to try and draw it out and see how far we can get. All right, so let's draw some axes. So we -7, 1. A mistake? Did I make a mistake, or what are you saying? 1, 2, 3, 4, 5, 6, 7. 1. A. Oh man, this is... So the circle... This is... Oh god. No, I'm actually... We need a formula. Oh, I see what you're saying with the mistake thing now, yeah. Hmm. Uh, this is a hard one too, Jabloni. I'm starting to get such hard problems. I'm trying to figure out how we can do this. Angle bisectors. I don't have to do this? Do you figure it out, or just like show me mercy? So I'm happy to try to figure this out. I just I don't know how to do it offhand. it's a bit too hard for me to try to calculate it, like by trying to set up equations of lines. I'm not really sure how you do it though. Maybe I have like half of an idea. Like if we start drawing this isosceles triangle, we know we have to fit in a circle of radius root 5. Can we set up a smaller isosceles triangle? Just work out what angle A is? We know the bottom would be root 10. We don't really know how far down it goes though, do we? I feel like it's something like this where you have to like you maybe make a smaller isosceles triangle somewhere inside it. I'm kind of losing where you go from here though. See, I'm sorry, like I hate not being able to help you out with our question, but like you don't have easy questions. I was hoping there's some kind of like theorem or something that could help us with this, but I don't really see one. Term b from the equation y equals ax plus b and substitute the points a. You still don't know. So yeah, we could make the equations for the lines between AB and AC. The thing is, we don't. We don't know what any of our constants are, I don't think, though. Like, we don't know what A and B are. Maybe we do know a little bit about it, though. Let's at least try that. Let's like call that. Just take a moment. Like call that B, call that C. For AB, just call it y equals ax plus b. For AC, let's call it y equals cx plus d. AB, we expect the slope to be greater than 0. And here we expect the slope to be less than 0. That doesn't... They do have point A in common. Which is -7, 1. But we can't really relate these constants in any meaningful way that I can figure out. So I guess that's where we have to use our circle in some way. But again, I don't really see how. My drawing is slightly off, isn't it? Um, yeah, I don't know. I'm still getting a little stuck here. Hey, Rishi, how's it going? Yeah, if I'll copy paste the question in chat. Ah, oh, shoot, it's too long to go in one message. I'm getting a little bit stuck on it, so if you do have a thought, please let me know. There aren't really many theorems about like inscribed circles, I guess. I was hoping that there'd be a whole bunch of them who just shoots whatever one is relevant. Math monks? Actually, do I have anything new on Reddit? No, I don't. Okay. If I did specific Isosceles. Can we do this backwards? Wait, what's happening? The radius of circle is root 10. We can call the equations by equating their perpendicular distance from the center of the circle. Yeah, I think you mean equating, not eating. Then equate those to each other to eliminate the length variable. Distance from the point to a line? Oh. Well, do we know the slope of that line though? Like, I guess we don't. We need to solve for that? What's the trick for distance from slope? Distance from point to a line. power value over root a squared plus b squared. What is a squared plus b squared though, in this case? Oh, it's this. This is what I was looking for. So yeah, okay, root 10 on top, and then a squared and b squared are literally a squared and b squared. So it'll give us another equation, but we still have 4 unknowns, I guess. I think I see what you're... So we'll get, oh, shoot. The distance from O... From O to AB is, this is root 5 because the radius is root 5. Over root, by my definition, oh wait, it's just, a squared plus 1 because the coefficient of y is 1. So actually this might be what we want. I don't know. Oh wait, I'm sorry. I'm saying it's root 5. It is root 10. Ah. I don't know why I was saying that. 10 over c squared. Okay. Actually, no, we already know the distance is root 5. This isn't, or root 10. Oh, I keep on saying it wrong, but. It should be root 10 equals, and then the formula, right? Yeah, I mean, so I was a little confused on that part. Rishi, like, the equation of the circle is the origin, but I think we're supposed to translate it over to be by the line, or to be over by A. So I didn't really know what to think of that part, but I think the equation of the circle just isn't quite right. I don't know. I feel like we're missing a piece of information or something, so I'm just a little bit lost here. Like, we should know where the circle is centered at least, right? That'd make this problem a lot easier. Because the equation of the circle is a circle centered at the origin, but this circle really can't be centered at the origin. And be an isosceles triangle. So I'm not sure if you're still Jabloni, I'm sorry, but like this is another really weird question. Yeah, that's a good point, Rishi. So yeah, Jabloni, I don't think we have enough information to solve this problem. I don't know if it's a translation thing or if it's just a weirdly made question, but I think we need to know like where the circle is centered, or some kind of extra piece of information or something. Um, I forget who the person... You found a solution? Oh. If it's in English, would you mind, like, saying what it was? Yeah, if you don't mind. All right, that person got their question answered. Interval -2, -1? Yeah, that means you're going from... You do 11 minus... We expect it to be a negative number. We do 11 minus 14 is -3 over -2 minus -1. Oh, they figured it out. Oh, because they did a minus there. That'll do it. But yeah, Chibone, if you're able to post the solution, I'd love to see it because I'm very confused. Oh, if they're asking a question like that, I'm okay. This person, if they don't know how to do this, they need like a general resource. I'm not going to do all these for them. Oh, let's see what a translator thinks of that. Oh, okay. I might need to plug it into a translator too, but I appreciate you translating it as well. Oh my god, I hate those problems. I don't want to do that. That's they're dropping a lot of information without a lot of context there. Let's move on. I might go do some real analysis studying. In a hot second here. Life-changing integration by parts trick? That's promising a lot. Conic sections get their solutions written themselves if the figure is right. Oh, I don't know for which one you were talking about. Because I was going through these questions too fast. Yeah, let's do some real analysis stuff. All of them? Oh, okay. Oh my god. Come on, there. And come over here. Then I need to... Oh, why are you up there? Why are you the way that you are? Okay. Oh, x minus 1/2 plus x squared ln x dx. Okay, that one I promise you I can do. All right, so I'm pretty sure. That one looks a lot simpler. X squared. You're gonna have to. Oh wait, maybe this is a harder one. I'm gonna need you to tell me if I'm writing this down right or wrong. How do you keep falling, Racer? So markers over there. So you have the integral as x minus 1/2 plus x squared ln x? Like that? Or is there something with the 1/2 being the exponent? Power? Okay. That makes it a bit harder. Okay. So my instinct is to multiply the ln x inside and do integration by parts twice, I guess. I don't think that integrates by parts. It might. Oh god, sorry, the whiteboard's being a little bit weird. Okay, just leave it. So I'm going to integrate that by parts. I'm going to take u equals ln x and dv equals x to the minus 1/2 dx. Derive u, so du is 1 over x dx. Integrate v, or dv. You add 1 to the power and divide by the new power. So it's 2 x to the 1/2. Now you do uv minus v du. 2x to the 1/2 ln x minus integral v du. 2x to the 1/2. Oh, good. Well, over x dx. Yeah, that works out at least. Let's follow this all the way through, I guess. 2x to the 1/2 ln x minus. So that's you do you subtract the exponents, so it's 1/2 minus 1 is negative 1/2. When you let me just write it on 2 different steps. 2x to the 1/2 ln x. So integrating x to negative 1/2 is the same thing I just did up there, I guess. Minus 4x to the 1/2. All right, so that's half the integral. Let me just check in on chat. Oh, that might be relevant, Rishi. I'm not sure, though. All right, so now let's do this part of the integral. It's going to be... We're going to have to do integration by parts twice. We might be able to avoid it here. I'm going to do the same thing. U equals ln x. Du equals 1 over x dx. And then I'm going to take dv equal to x squared, I think. It's normally backwards from how I usually do it, but I think this will work. So uv v du, yeah, this will work. 1/3 x cubed ln x minus 1/3 1 over x times x cubed is x squared dx. Okay. So 1/3 x cubed ln x minus 1/9 x cubed. Okay. So we know what that part of the integral is, we know what that part of the integral is. We have to combine these two, and that's our answer, plus c. Two x to the 1/2 ln x minus 4x to the 1/2 plus 1/3 x cubed ln x minus 1/9 x cubed plus c. I'd say that's our answer, I think. There's no real like terms that we can meaningfully combine here, so I think that's just it. Does that make sense, Jabloni? I think it is called integration by parts. It sometimes gets shown a little bit differently, but it's the same idea. You might see like f and g or something like that instead of b, u, and v. Whew. Makes sense? Okay, awesome. I'm glad I can at least do one of your questions. You're a boss. I don't feel like a boss. I'm 1 for 3. But thank you. I appreciate it. Yeah, Rishi, that's what it seems like. All right, so unless there's any questions from chat, I want to do some real analysis studying. Sure. This is what we're going over in class today. We got as far as 6b. Well, really 6a, but 6a is basically the same as 6b. So Rishi, this is for a real analysis class that's being taught on Twitch, and it's like the worksheet that we're working through today. We didn't get through it all, so I'm kind of working through the problems we didn't get to touch. Smiley face of x? Oh my god. Zach is out of control. I guess I should do C. I kind of want to skip over 6C, but I probably shouldn't. Let me look at what we were doing for 6A. So our work for 6A was down over here. In this area here. And so how do we do this? We looked at the limit. It's just a definition of a derivative with limits. Here we are given f prime of x is greater than 0, and f is increasing. And so if this is greater than 0, then f of x plus h, either both the numerator and the denominator are positive, in which case there's a positive, which implies that f of x plus h is greater than f of x, which is an increasing function, because h is positive. Or if h is negative, then both are negative, and f of x plus h minus f of x must be less than f of x. Okay. All right, so I was thinking that the argument for C, which is f prime of x sub 0 equals 0, being a minimum or a maximum, we kind of already made the argument as far as I thought. Over here, so if you look at the limit as you go from the left, you get that it must be greater than or equal to 0. You go the limit from the right, it must be less than or equal to 0. Well, is that necessarily true? Okay, maybe this is where the distinction comes in. Oh, no, yeah, it is. If f prime of x equals 0. Wait. It can be neither a minimum or a maximum, though. Because if you have f of x equals x cubed, then f prime, you get what looks like a critical point, but it's not a minimum or a maximum. I'm gonna message this to Zach, 'cause I think that's a typo. I feel like you need some extra condition here, like f double prime not equal to 0. Oh, wait. The question is prove or disprove. Ah, so we disprove it. Okay, maybe that's the point. Okay. Do I even need to write this down? Because we can name. I'll write it down. Why not? All right, so for part C, oops, oh God. Okay, so for part C, I guess we're going to disprove it. But f of x equals x cubed. Then f prime of 0 equals 0. That's a pretty bad cubed. How to show there isn't a minimum or a maximum? We rely on probably part A and part B, right? Wait, am I missing something? So, oh man, I kind of want to ask Zach if this was the intention. Because, I think I'm going to do that. Because for it to be a minimum or a maximum, you need to have this be true. Actually, yeah, so you need to have, oh my gosh, wait, I'm trying to think if I'm misinterpreting the question or not. If the derivative is equal to 0 at a point, there's a maximum or minimum of f at x sub 0. I'm going to message Zach, I think, and ask if that was the intention. Okay. Okay, so I just want to message Zach Ballin to check my understanding, and if it's a potential typo, I want to point it out so that it gets fixed for section 2. I guess we'll move on to number 7 then. F of x equals a minus root of x squared. Interesting that we're given that rather than the absolute value of x. On the interval a minus a to a. To plot it without technology. So is this going to be only one part of an absolute value function? Like, what I'm thinking is, I just try a few values for a and look for the pattern there. Just to be safe, if f of x is a minus root x squared, are we open or closed in interval? Open? Okay. Minus a to a. So this is basically the absolute value of x, and if you're going from negative a, we start from 0 and we end at 0, I guess. Huh. So are we going to get a maximum? As we go from negative a to 0, I think it's going to be minus a to a, then a over 2. No, 0. Or a. Because this includes 0. And that'll be where that becomes a maximum. So we have that, there, to there, I guess. So that's a that's a slope of 1, because we're going from minus a to a. Y equals x plus a. And that's a slope of negative 1. Which again is just like absolute value of x. One's positive, one's negative. And that makes sense in my head when I plug in 1 for a. Okay, so I think I'm satisfied with that graph. to calculate f prime x, and is there a maximum or a minimum? So f prime x, we're gonna have to do, this is an example of a continuous function having a non-continuous derivative. So from here to here, it's 1. How should I write it? Minus a is less than x is less than 0. And minus 1 when zero is less than x is less than a. You'll notice that 0 is included in the initial function, but it's not included in this function. That's because you can't differentiate at a corner. So the derivative is just not defined there. Is there a maximum or a minimum at any point? Well, there is. The maximum is still a. You just can't get that with a derivative. Okay, that's actually kind of an interesting thing. There is no minimum. There is an infimum, but a, or like 0 itself isn't included in this. Or, you know, x equals a is not actually included, and x equals minus a isn't actually included. So you'd say your infimum is 0, but your minimum doesn't really exist because it's an open interval. Okay, interesting point being made. For any a, b, c, d belongs to R, does the function smiley face of x, ax plus b over cx plus b have a maximum? Really? Oh, cx plus d. Oh, okay. I honestly, I read that correctly in my mind, or how you intended it. I don't know if you saw my message, but for 6C, was that a typo? Or like, was there an issue there, or did I understand it right? It's worded correctly? Okay. So then I'll try my hand at I guess disproving it is what I'm thinking. Because of my x cubed case. Counterexample? Okay. I'm still thinking about how you actually like, how to actually phrase it. Because I was getting a little tripped up on that. So you can't use like rules, phrase it so that it's true? Or no, sorry, I could just like f of x equals x cubed. Is that enough for an answer or is that enough of a statement? Or do you need to actually show why it's a counterexample, I guess? I was thinking on showing why it's a counterexample. Show why? Okay, yeah. So that's what I was like having some trouble with, because like I can show it's increasing before and after. Oh, I guess that, okay, maybe that's the key. All right, let's try that. Okay. Oh God, what did I just do? No, it's okay. I just accidentally hit the wrong hotkey, but it doesn't actually change anything. So yeah, I was getting tripped on like I noticed for Rolle's theorem and extreme value theorem, we have like, you know, those nice clean like intervals and some more stipulations, but when you just get like a generic interval and oh shoot, what am I trying to say? Rolle's theorem and extreme value theorem You'll be in and out? Oh, no worries, Zach. Wait. F prime of 0 is not equal to 0 in problem 7? Oh yeah, no, I excluded 0 from my definition of F prime. It wasn't defined there. I said there's a maximum there. Yeah, okay. So I defined that there's a maximum at x equals 0, but it wasn't. You can't get that from the derivative. F of prime. Okay, that's fair. S with a. I mean, I think that's why you gave it as root x squared, so it still looks. It doesn't look like it's a piecewise function. So let's say with the piecewise function, you have to be careful, but that one's in one piece, I guess. All right, I see you. Okay, so we have to show why x cubed is a counterexample. So let f of x equal x cubed, then f prime of x equals 3x squared. This might be even too much, but and f prime of 0 equals 0. Now I want to use like okay, here's what we do. F prime of x is greater than 0 for all x. Oh, greater than or equal to 0 for all x. Maybe for all x strictly greater than 0 for all x not equal to 0. Like that, I guess. By prompt 6a, f of x is increasing for all x not equal to 0. Since f of x is increasing, I guess, on both sides of 0, putting it in quotes because it feels sketchy. X equals 0 is neither a min nor a max, is what I'm thinking here. Oh, I messed up the capture. It's freaking. I need to get rid of the hotkey. For whatever reason, there's an overlap in my hotkeys with Firefox, and it happens to be the same one I use to turn my webcam off. Okay, so I think that's at least the idea for 6. Maybe I could phrase it better, but I think I have the idea. That only leaves 8. Oh god. Okay, there. So for 8, what are we working with? So this one, I'm... Smiley face of X, man. ax plus b over cx plus d have a maximum, a minimum, why or why not? Technology is definitely allowed. Oh, okay. I'm about to try and figure out a graph for this. You definitely have one vertical asymptote. Definitely seems like a situation where Desmos can shine, though. Gonna have 4 different sliders, though. I was thinking they might want to divide them. Let's see. Let's try not dividing them, though, at first. Okay, so if they're all 1, you know, you just get y equals 1, naturally. Let's try a couple of unique integers. Make this like 5 to make sure there's no like cancellations. Okay, so we shouldn't get any like unexpected cancellations here. Okay, so that makes sense to me. That should all be different versions of 1 over x if you were to divide these. Just kind of shifted and stretched or compressed. We should have a maximum, a minimum, why or why not? Well, let's say, of course, this has no minimum or maximum because it shoots out to positive infinity and negative infinity. So we're defined for... Okay, yeah. But there are A, B, C's, and D's that'll make this into a horizontal line. If we already saw 1, if they're all equal to 1. Or if they're all just the same thing. Oop. So, yeah, and then I think you can even translate this horizontal line up and down if they're like scalar multiples of each other, because I feel like it's almost like linear algebra, like with being linearly independent or dependent. Though it's probably bad to involve that, but this reminds me of where we're looking for things where they become multiples of each other with the top and bottom. So we can have, if A equals k times c, I guess, for some real number k, and B equals k times d for some real number k, you have a maximum and a minimum at y equals, or at just k. Is there a different situation where this becomes something else? So let's try having them all be equal. You can just type in for these, can't you? Yeah. And now let's just try varying one of them at a time and seeing how the function behaves. What's that transition point? Oh, duh. So, okay, I don't imagine we're gonna get... Whoa. Oh, of course, it becomes a line when c equals 0. That doesn't have minimum or maximum though, so that's not important for the question at hand, I guess. Well, it's good to know, but... Whoa, wait, what the hell? Oh, it's still... Okay, no, it's just a lot smaller. All right, so let's go back. Let's vary d. If d equals 0, we just don't have the translation, I guess. Okay. Yeah, that makes sense. So it seems like we only have a minimum or a maximum when the top and bottom are multiples of each other. Because that transforms into a constant function. Okay. I'm wondering if there's anything else that I don't think I'm missing anything. I'm trying to figure out if there's any kind of other meaning that I can get out of this question. Like, how would I phrase, like, I guess it's unbounded, which is the issue for most sides of A, B, C, and D. I guess that's the heart of it. And I guess that means we've, I mean, I haven't, we did leave a few things to the reader, right? Like doing B. But, or like a 6B. I think another thing too. Oh yeah, that one, 4. There were some fun limits in the last one though that I kind of want to look at even more though. So I got I did sin x over x, which I was actually kind of happy I was able to do that. So last time I was studying, I did A here, which is a lot of fun. I also did B, although I didn't finish it on stream. I thought I did something wrong and I was stuck, and then I looked at it again after I stopped the stream. I was like, oh wait, I was literally right there. I just need to do one more thing. So I've done this. We could... Oh yeah, this one... I looked this one up, so I didn't realize I'd have to prove it later on. This was involved in the proof for sin x over x, to be honest, so... There's a clever way to do this one, which yeah, so well, let's try this one, see if I remember the trick. Because it was an algebraic way to do it, which I appreciated because it avoids, I can just rewrite the problem. It avoids any weird things that we haven't proven yet. And I assume that L'Hopital's doesn't apply to this. For some reason, sin x over x doesn't. I don't actually know that. Okay. So we have the limit h goes to 0, cosine h minus 1 over h, right? Right. All right, so the solution that I saw in mine, I believe, if I remember right, and I don't want to look it up yet, was to multiply by cosine h plus 1 over cosine h plus 1. And that gave some pretty neat simplifications. So you get cosine squared h plus 1 over h cosine h plus 1, which that on top is sine squared. Over h cosine h plus 1. This isn't valid? Minus 1? It's correct, but for the wrong reason? What minus 1? Oh, you're right. I saw that as -1 in my head. I already messed up one trig identity earlier when I was doing an integral, so I just feel like I should mess up two. Okay. Then what do they do after that? If you plug in 0, does that get you where you want to be now? No. What did they do here? Oh, there's something neat. Do you do a half angle? No. Do you? It might be a half angle. No. No, now I don't remember it. Split into two factors? Oh, that's right. Because you have sine h over h in there. Times the limit as h goes to 0. Sine h over cosine h plus 1. That we've already proven to be 1. This is 0? We don't expect 0 though. Sine of 0 is 0, and then on the bottom we get 2. That doesn't make sense. The whole thing should equal 1, but I'm getting 0. What else did I do wrong? I guess I need to look at the proof again or something. You should get 0? Oh, okay. All right, well, thank you for telling me that. I was like, I need to how else could we possibly get 1 of that or something, but okay. Thank you for telling me that. So actually, I kind of did this the last time that I was studying. I'll test it. Yeah, exactly. I might do it again, but let's start with 9a here. And I might skip 9b because there's a debate about sine x over x and whether you can use L'Hopital's for it. So I just went and derived the derivative of sine to kind of try and show the person why you can't. All right, so start with e to the x. Oh, who's that? Altair Sepius, thank you for the follow. Welcome in. I'm just doing some studying for a real analysis class that e to the 2i pi is teaching, but if you have any questions, please let me know. All right. So we have d by dx e to the x equals e to the x, right? And I didn't write too high on the board. Good. Okay. Two good things. So let's take our good old limit definition of a derivative. How do I always write that wrong on the first try? H approaches 0. E to the x plus h minus e to the x over h. Okay. So I guess what I'm going to do is factor out the e to the x. That's what jumps out to me. Oh, okay. Well, that becomes very easy. E to the h minus 1 over h. We've already proved in a different problem that that's 1. So we actually use the binomial theorem to do that limit. We basically have the power series for e, which I didn't expect, but it was kind of cool to do that limit. All right, so once you have that fact established, I guess the proof is pretty easy for e to the x. All right, I guess let's try it for cosine. I mean, we can do it again for sine. May as well. All right. So d by dx of sine of x is equal to limit as h approaches 0, sine of x plus h minus sine of x over h. All right, so we need a trig identity, the sum one. Let me bring it up quickly. Sine theta cosine phi plus. Okay. So if we apply a trig identity to that sign, we get sine x cosine h plus sine h cosine x minus sine x over h. All right. Now we want to split this up into two different limits. Limit as h goes to 0. We want, I think the sine of x's to go together. Yeah, this is where I ended up with the cosine. I think I hand waved the limit when I did this the first time, but I did just prove it now, so. Like that. Okay. So this one, we already proved that cosine of h minus 1 over h is 1. The sine of x can just come out front, so you just get sine of x. 0. It's 0. So you just get 0 times sine of x, which is 0. Oh god, that's going to mess me up. Sine of h over h approaches 1, which is, I proved a different time, and I don't want to redo it. It actually wasn't that bad, though. So you get 1 times cosine x, which is just cosine x. Okay. It's pretty easy once you have the actual like limits already proven. We can do the same thing for cosine x. All right. So then for cosine x, we do limit as h goes to 0 again of cosine. I think this will be pretty much the same procedure, but let's see how it differs. Let's do another trig identity on that cosine. I think it's gonna be like, for cosine, I don't know if you match the sign, but it's like cosine x, cosine h. You reverse the sign. Okay. Limit as h goes to 0, cosine x, cosine h, minus, because that's plus, so you do minus there, sine x sine h minus cosine x. So yeah, from here I gotta imagine it's gonna be the same procedure. You group the cosine x with the cosine x into its own limit. Minus 1 over h minus limit h goes to 0. Sine x sine h over h. Hey, that's familiar. This becomes 0 because of those two pieces. So you get minus sine x times 1, which is minus sine x. All right, pretty easy. Well, the work involved in these two limits isn't necessarily easy, but once you've done the work once, you don't have to do it again. It's a nice part. All right. Hey, Brayden. So this might be the end of the last worksheet in the kind of fun limit problems that we had. You want to ask something? What's up? Yeah, it's like nothing else on the sheet. All right. Let's go check in on Reddit again. Hollow matrix, I never heard of that. Does problems have a section specifically on like, oh, what the heck did I just do? Oh, you can take a screen. Oh, that's kind of funny. Okay. I don't know if they have like a wrap up like overview section for when to use all these different techniques. Integration strategy. Oh, maybe they do. Explanation of how to approach integrals and finding the correct technique. Difficult integrals often still require exploration. Exploration and trying things without being sure they're going to work, though. ln of 1 plus x squared. Ooh. Let me make sure it comes out. Like, let me make sure I think it's going to be integration by parts. I want to make sure it's not going to be something that's like impossible though. So I'm going to plug it into Walker Alpha quickly, but as long as it's something that's super nasty, I should be able to figure it out. Oh, that's not too bad at all. All right, yeah. I was make sure it wasn't like some crazy thing. On the 100 integral challenge? Oh, okay. Well, hopefully, as long as Penn Center isn't watching, you know, I'm sure it's okay if we do it. So we have the integral of ln 1 plus x squared dx. So You can't really do a use-up with this because you don't like have one composite thing. With ln, if you have ln of something, you can often. I don't know if saying often is a good thing, but how this? I've seen before the proof for the integral of ln of x, and that involves integrating by parts. And I think we need the same technique here. So with ln x, you integrate by parts with u equals ln x, and dv just equals dx, because you have an invisible 1 times ln x there. So the 1 is the other like part that you're integrating by. So over here, I'm going to do the same exact thing, except u equals ln 1 plus x squared, and dv equals dx, which means you derive u, so you get u equals 1 chain rule 2x over 1 plus x squared dx, and you integrate that to get v equals x. The formula for integration by parts is u times v minus integral of v du. So u times v is x ln 1 plus x squared minus v du. Integral get 2x times x is 2x squared over 1 plus x squared dx. Then you can solve that integral, which I'm still trying to work out. So in the steps of the actual solution, is that, well, sorry, I might have misunderstood you. So I guess I gave you the first step, which is integration by parts, but do you want me to stop there or do you want me to keep on going? An explanation of integration by parts if you want it. The next part is it solves another trick. To integrate 2x squared over 1 plus x squared. You have it open? Okay. So how far do you want me to go with this problem, I guess? Like, do you want me to stop here so you can try and do the rest yourself, or right. You name u and you name dv. You need to figure out what du is and what v is. This is basically your formula. If you want to see an example, like this is a much simpler example of integration by parts than the one that I just showed. The one that I just showed. Because the one I showed is kind of a weird exception to how you normally integrate by parts, but this is a much better like showing of the technique and when you would use it. Okay. 20 minutes, nice. Okay, that makes it a lot harder. And you can definitely do integration without knowing what it means without calculus. But yeah, I'd say step 1 is integration by parts. Step 2, how would I describe step 2? I wonder if they have a little section on it here, although I kind of doubt it. It's not actually partial fractions. I wouldn't trust ChatGPT for anything. This example is too complicated for what I'm trying to get across. All right, and if you... Yeah, without trying to tell you exactly what to do here, I guess I would link you to this page. Look at example 6 for how you do the part after integration by parts. And those are the most important steps to do the integral. Also, above it isn't really relevant. Well, I mean, it kind of is, but... example 6 is the most relevant one. So let me know if you want more guidance on it. Otherwise, I'm just going to leave you with it at that. Actually, where was I? I was, oh yeah, I was looking through Ask Math. Generally the most difficult. Can you just read the website that tells you that what the easiest way is? I feel like I linked them to a resource and they didn't even like it, so I'm just gonna not. Highlight is the original question. I think they're going about this all wrong. So let's see if we can kind of give them what to do for part A, and then it'll hopefully see the pattern. To factor just the x's and just the y's, not mix them together. Using I could use part A. It's an example. 16x squared plus 4y squared. 96x minus 8y plus 84 equals 0. Okay, group the x's. And group the y's, then complete the square on each individually. Let's copy that down. Paste that over there. 16x squared plus 96x. What's the completing the square on 96? 16. It's like minus b over 2a. Should b over 2a? Oh yeah, but there's a... No, it's not minus b over 2a. I guess it doesn't matter because you add and subtract it. Plus, so 96 over 32, which is 3, plus 3 minus 3, plus 4y squared, in parentheses, minus 8y, plus 1 minus 1, plus 84 equals 0. So 16 are the 4x plus... Wait, that can't be right. Why did I only get 3? Is it a squared? You have to square root. A squared. You do have to square it. That's why. Okay. We still get just 3, don't we? That's still not right. So it's 16x. You don't square root. Well, no, it has to be 4x. But 4x plus 3 squared is definitely not like the 96. It doesn't make 96, it makes 24. Why am I getting stuck with this? Am I doing my b over 2a? Why is this not, like, do I not remember, like, Algebra 2 or whenever you learn this? It is always force the quotient to be 1. That might not be bad. We can do that, I guess. Maybe that'll make it more clear. 6. This is where we want, I guess, +3 and -3. X +3 squared -3 plus 4 y -1 squared plus 1 plus 84 equals 0. And then we need to bring the constants outside. So the 3 gets multiplied by 16 on the way out. The -3 does, rather. -48. Plus 4. So 48, 84 minus 48, well, or 88 minus 48. We should just get 40, I think. No. 84, oh my god. 84 plus 4 minus 48. It is 40. But I don't know why that, okay, never mind. But not that bad at math, I guess. So this is going to be an ellipse, right? And for an ellipse, you make it equal to 1? Or a hyperbola? No. Ellipse. What does it mean when they're both negative, though? Go away. Oh god. Why do we, like, we shouldn't be dividing by a negative number here, right? If we do get a negative number, well, we can throw the negative number inside the squared, can we? No? No, it doesn't make, can we? Why is this so weird? My sign is wrong. Let's give it the original problem to Wolfram. See what it says. I did mess up a sign. 16x plus 3 squared. 4y minus 1 squared. I got plus 40. They got minus 64. How did that happen? 16 times minus 3 is minus 48. Because it... What? What did I mess up here? Something to do with this and this, I guess. It's 96 over 16, not 6. It is 6. Why am I wrong? I must be. I wish Wolfram would give steps for that. Even then, they wouldn't show me all the steps, would they? How do you possibly get a number less than 84 here? Okay, what we can do, let's keep copy pasting our steps in until something changes in Wolfram. Same thing. Can you teach about summations of in A of n and shit? Do you have a specific question? I know generally about them, but it's a big topic. This is still the same. Convergence and divergence of infinite sums. Well, I guess like, do you want to see them with a specific test or like what? So if I know, like, you know, if you're in a calculus class and you ask about like any of these tests, like integral test, geometric series, comparison test, I can help with these, but you know, I can't just talk about every single one like that easily. Oh wait, that's the problem. That's a 9. I forgot to square it. Oh my god. All right, so it's 16 times 9. That's what my problem was. I don't know, let's say I'm sorry, because I'm happy to like help. It's just like, it's hard for me to just have someone else like, you know, teach me everything. I need you to like narrow it down a bit for me. All right, so finally I found my mistake. +4 plus 84. Hopefully, is negative 64? Minus 56. Oh god, I still didn't do it right. Back some more. All right. Thank you, Fishy on 6. If you can just name a test, I can find an example problem of it. Thank you for the follow. But yeah, I guess that's kind of like, it's hard for me to like do much else, I guess, right now. I think it's supposed to be -1, and that's my issue, so it's -4. It's a little bit tricky. Okay, yeah. Because we're still taking in the +1. It becomes a -1 inside there, but it still turns out to be the +1 there. Okay. Oh, jeez. Okay, finally. -64. I need to update all these after it. 144, -4. 64. X plus 3 squared over 16 over 64 is 4. Y minus 1 squared over 16 is 1. Let's give it back to the original problem just to make sure I got that right. God. Okay, this is good. Okay. So I just gave the person the answer to part A, which they showed their attempt here. They were kind of off on the wrong track. Oh, shoot. Okay, other people kind of got on at the same time, but... oh, well. Sketch a graph of any function that satisfies given conditions. F of 3 is undefined. Its limit as x approaches 3 from the left of fx is -1, and that looks good. Fx is x approaches 3 from the right is 2, so that looks good. If it's a finite discontinuity, I guess that would be a finite discontinuity. Infinite discontinuity would be like that asymptote over there. Oh wait, that has infinite discontinuity. I read it has and finite, and that made sense to me for some reason. I guess it's an infinite discontinuity. I haven't heard that term for myself. This one, Jed? I don't see anything wrong with it. I haven't heard the term infinite discontinuity before, but I've got to imagine that's going to be it. Oh yeah, and I didn't post because someone else already said that looks good, and I don't have much more to say. All right, I skipped over this geometry one, but you know, we can at least look at it. Oh, okay, no worries. P comma P cubed, like on curve y equals x cubed, okay. Ooh, a line through P with gradient M. What? Is gradient slope? And sure, that's not true for any point P. Well, I guess that if P is allowed to be equal to A or B, then I guess this is always true. No, They can't. You can't have a perfectly horizontal at x equals 0. This doesn't work. The line only intersects the curve once, ever. See, I don't know what this is supposed to be about. I haven't done that type of question before. See a ton of other problems to do. Simple geometry question, I'm just a bit dumb. This is why, if it's simple, why is there 10 paragraphs of introduction? Oh, x ln 1 plus x squared minus 2x. I didn't actually work out the integral, so I'm gonna go back to Wolfram Alpha. I won't show my Wolfram Alpha, I guess. It'll take me another minute to it took me a little bit longer to actually work out the integral for myself, which I can do. X ln 1 plus x squared minus 2x plus 2 arctan x plus c. Wow, you got it. Wolfram Alpha factored out the x for whatever reason, but I would write it the way that you wrote it. So nice job, Brayden. Oh, look at that graph. That's kind of cool. I don't want to read an essay. Yeah, it's much more like slanted, I guess. Let's take another look, I guess, to the math Discord, and then if we don't find too much, maybe I'll wrap things up. No clopin. Suppose that f of pi over 3 equals -8 and f prime of pi over 3 equals 4. Let g of x equals f of x sine x. Ooh, h of x equals cosine x over f of x. So g prime of 3, you have to do a product rule, is f prime x sine x plus f of x cosine x. Oh, basically, yeah. What did they do? No, 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 no. G prime x is equal to f prime x sine x plus f of x cosine x. And then you plug, oops, in x equals pi over 3. That's it. That should hopefully be enough for them to do that. Let's see if they get back to me. Ooh. I think for this, you do expected or payout times probability. So a 5 or less, you gain $49. Well, there's 13 like unique types of cards. So 5 or less is 2, 3, 4, or 5. So you have 4 out of 13 times 49. Let me type this down in Wolfram. 4 over 13 times 49 minus, we lose $26 in any other situation. So 9 over 13, because there's 9 other cards, times 26. So you expect to lose money in this game and you shouldn't play it. You expect to lose minus $2.92. Let me look up probability expected value. I just want to make sure that I'm right with that. I'm pretty sure I am. So value like pay. Hey, Fire Knight GG's. When does the stream end? I'd say probably within half an hour. I don't have a scheduled like end time, but about like half an hour or less. And I'm definitely gonna raid out someone who's live doing math stuff. Do you think you're gonna have a question, or you're just asking to because you're curious? Display each outcome by its probability, add up the products. Ah, okay. So yeah, I'm right. I just wanted to confirm that. Let me look at this person. Oh, this looks like he said the quotient wrong. Slash fraction. Derive the numerator first, so minus sine x f of x minus cosine of x f prime of x over f of x squared. Oh shoot, h prime. Okay, for this person, you basically take the expected payout times the probability and add everything. So 49 times probability of 5 or less plus minus 26 times probability of more than 5. Okay. The length of the minute is 150% the length of the hour hand. What distance will the tip of the minute hand move in 45 minutes? You're given the hour hand is 36 millimeters. So this is it's called sector length or arc length, whatever, like, you know, the partial part of a circle is. You know the radius. Someone else is already replying in it though. The midpoint rule. So we're talking about a Riemann sum or something? You definitely would want to... Oh yeah, they closed it anyway. Will optimal function cross its midline? Do you really need arc cosine for this? Why can't... How does integration relate with summation? Well, there's two very different answers that I could give you here. So if you're still talking about like convergence and divergence of infinite sums, oh no. What? Is my internet out? Or is this just... No? Okay. Oh no. Okay, well you know, I don't get polls anymore, I guess. You love learning new things? All right. Let me look for a different website. Because I'm not exactly sure which one you're talking about, so I'll just explain both. See, because you asked me about infinite series. Well, yeah, because you asked me like an infinite series and see if it converges or diverges. There's something called the integral test for an infinite series, which is if the series that you're given, if you made it into a function, if that function is continuous, positive, and decreasing between 1 and infinity, then if the integral converges, that infinite sum must also converge, and vice versa. If it diverges, it also has to diverge. So as long as your conditions are met, you can consider this infinite series as an integral for the purposes of convergence. So that's the way that I assume that you were asking that they're related. Wait, oh yeah, what's up? Sorry, I can't talk. Basically, whatever's inside the summation, you make into a function. Do they give an example here? They don't. Oh, let me find an example problem. Okay, so like, if you have the series of 1 over n squared, perimeter of the area? I'm not sure what that would be about, but if you have 1 over n squared as a series, you can treat it like the function 1 over x squared and integrate that. That's basically the idea. Where you're summing up all these things 1 over n squared, you can treat it the same as 1 over x squared. And that's kind of like the idea of why the integral test for an infinite series can be helpful for testing convergence or divergence. Does that make sense? Like, I don't... I don't know what I think about it graphically like this. We keep throwing out like area and perimeter. I'm not sure. Like, so yeah, you can form these rectangles and their area is determined, like, the height of each rectangle is determined by the function. And it actually builds into the other interpretation of your question, which is a Riemann sum. And the Riemann sum is normally taught way before you learn about like series in calculus, like before you learn this integral test. The Riemann sum is usually how integrals are introduced to calculus students. And a Riemann sum is the idea that an integral is the area under the curve, and you could approximate the area under the curve by drawing rectangles like this. So you can tell, like, these rectangles they're almost all like a little bit over, like, the estimate is not going to be perfect here. Like, some of these rectangles go over, some go under, and it's hard to tell if you're going to be exact. But if you use smaller and smaller rectangles that go to the point of being infinitely small, like, I shouldn't say small, but thin, you get a better and better approximation to the point where they become equal if you go like infinitely thin. And so that's the other way that, I mean, I think they're really based on the same idea, but oh, okay, fishy. Trapezoid rule, yep. It's normally a better way to, or it gets you like a more reliable estimates quicker than just rectangles. And so I'm reading back like what you were saying earlier, and so now I think I get it a bit more. So yeah, you do end up with like a, you end up with this product of the width of each rectangle times the height, which is the value of the function. And the idea of that width times height is where our notation for the integral kind of comes from. So notation is interesting. Yeah, it is. It's kind of, it can be a pain, but there's some kind of like fun problems in calculus when you get into doing stuff like the integral test, ratio test, limit comparison test, stuff like that. 1 over n, it does diverge. Yeah, it's called the harmonic series. It's a little bit special because it's kind of like right at the breakpoint of when a series could start to converge or start to diverge. If it's 1 over n squared, that does converge. I still can't get it right. All right. I assume they're talking about for... It does, yeah. Actually, I hadn't even made that connection in my head. Yeah, when you integrate 1 over x, you get ln x. Let's verify what they got for the product rule part. So for product rule, they should get you can integrate ln x, but if you integrate 1 over x, you end up with ln x, and ln x like diverges as it goes to infinity. So g prime of x here is f prime x, and f prime pi over 3 is pi over 3 times sine pi over 3. Sine of pi over 3 is 1/2, so you get pi over 6 plus 4 times root 3 over 2. So yeah, this person... I told them what they should get for g of x. Yeah, fishy. It's x ln x minus x if you integrate ln x. Oops. Saying the answer. So Wolfram Alpha writes it a little bit differently, but x ln x minus x. Kind of a cool looking function too. Like a little swoosh. I think that type of question has a name for people who study that. Like, there's things, they don't really ask in reverse, like it's something, how many times can you differentiate something? I think it's still basically the same question though, just in reverse. And I forget what the name of that like branch of math is called, but in general, I think you can integrate as many times as you want. We might not know how to do it, but it should exist. Okay, yeah, I would take Zach or e to the 2i pi's word here. Needs to be cn to be n times differentiable. Not everything is always differentiable. Just something like discontinuities and things like that. You can introduce discontinuities by like differentiating, I guess. So I mean, it's still differentiable, but it go. I don't know. I know that must show off your analysis knowledge. We're actually just looking at an example function earlier in the stream. Where it is an n times differentiable. Oh gosh. So it technically is differentiable. You just get a discontinuity, the one that I was thinking of. I would imagine they... You know, you really make me stretch my knowledge here. Let me, in a good way. Wait, I was thinking that that is differentiable. You just can't define it at x equals 0. Because that's the example, like that's basically the example that was coming to mind. Okay. So, greatest integer function. Oh yeah. It's not differentiable on R. Okay. That's the, I guess, distinction. But yeah, you need either discontinuities or what's called a corner or a cusp. I think it's like absolute value of x has that like corner there where you can't really define a derivative. So even though the original function is like in one piece, so to speak, by differentiating it, there is a point on this where you can't define a derivative. Because like I was thinking of things like how 1 over x is continuous, you just take out the discontinuity. And I was like, oh, so if it's differentiable, you just take out the non-differentiable part? Square root of x cubed is differentiable on 0 to infinity, but it's not twice differentiable. Really? You get 3 root x over 2, 0 to infinity, open. So if you differentiate this again, you get 3 over 4 root x. So I think that seems okay, if you're not including 0 in the first spot. You like? This is hard. Okay, I'm glad I'm not like the only one who's having like a hard time describing it well. You love that definite absolute value integration? Yeah, it can be tricky to deal with. What's the deal with this? Like, they still didn't do the formula right. And I told them how they should do it. But I said it should be. Example we're going to look at maybe on Thursday. Oh, okay. Well, Fishy, if you're interested in that questions like that, I highly encourage you to go to Zach's real analysis class. It's Tuesdays and Thursdays, and there's 2 sections each day. Section 2 starts in 1 hour and 40 minutes. Wait. Fuck. I don't know why I added 1 hour. I'm sorry. 40 minutes. I was like, oh, let's add 1 hour because for me the hour should be 6. Right now it's 5. And then like, oh, but we also need to make the 50 into 30. So I added them both. It's almost the daylight savings time. Oh, I haven't even been keeping track of that. Yeah, sorry. It's just in 40 minutes, not 1 hour and 40 minutes. Oh my god. Wait. Oh, did the person close their question? Oh, okay. Is this true? Compose any function with tangent of x and the integral from 0 to pi over 4 is 4? Or, well, it's going to be the actual question. I doubt I can do it. I'm just kind of curious what it's going to be. Let's give the person a minute. I don't know if it's true, Fishy. It might be, the question might be like, prove why it's not true or something like that. But if it is true, that is super cool. That is. Oh. It might be given these 2 things, figure this thing out. I have no clue how you do that. It's probably not true in general. It's almost definitely not true in general, actually. It will be a super cool fact, though. In Fire Knight, yeah. Or wait. Oh, sorry. Fishy. Yeah, I mean, hopefully the questions aren't too involved because I'm not playing the stream for a ton longer, but Fire Knight asked first, so Fire Knight, I'll look at their question first if they are able to get in chat soon. You can either type the question out there in chat or put it in my Discord. And if you do put it in my Discord, I have this math homework help forum. That's probably the best place to go. And I'll x times s value of x. Oh, okay. So in the meantime, let's look at that function. But yeah, both Fire Knight and Fishy, whenever you're ready, just feel free to type it in chat or put it in the Discord. Either's fine with me. Oh wait, let's see, you both hopped in potentially, so thank you for doing that. That's what x-apps about. Oh, I guess it's like a parabola, but also not. Okay. It's like a parabola where you flip it. That's kind of funny. So if you differentiate it once, you eliminate x equals 0. What if you try to differentiate that again? 2x squared over x? It turns into... Oh, okay. I'm not sure. Okay, well, I'm going to prioritize the questions there, but... Oh, yeah, math discussion works too. Oh, I can definitely do this. So, to solve this one for x, see if I can... Multiplies to 40, adds to 22, so 20 and 2. Okay. So have you been taught, before I actually go off the rails with this, have you been taught to do these in a certain way? Because I have the way that I would do it. It's not the way that everyone was taught to do it, though. I'm happy to show you my way, though. You sub... Okay. I'll just show you the way that I approach these then. There's multiple ways that you can do these, though. Just know that. Okay, so let me write down the problem again, or let me look at the problem again. 8x squared minus 22x plus 5 equals 0. 8x squared minus 22, oh my god. Plus 5 equals 0, right? Okay, good. So, the way that I was taught to factor these that I still like to do, some people call it the AC method. I was taught like the X method. That's a lot of different names, but you do A times C, basically like whatever your leading coefficient is, times your constant. So 8 times 5 is 40. You have to name a numbers that multiply to 40 and add to negative 22. It's a little bit more complicated when it's an 8 and not a 1. So there's a couple different things that we need to kind of consider here. And these, honestly, I do these a little bit like a guess and check way, so I'm going to show you probably a second way to do it as well. So there's two different ways that the answer could look here. It could be x and 8x, and we have something here and something here, or it could be 4x and 2x, and we have something here and here. I'm not sure which one is right yet. I think Fishy just like put the answer in chat, but I didn't really look at it. It might actually both be right. So we need to make sure. So actually, I should back up. I got these two because I know they have to multiply to 8. Like the x times 8x has to make 8x squared. The 4x and the 2x has to make, or makes 8x squared. If 8 had more factors, we'd have to do more with this way. Actually, maybe so. The 8 times 5 equals 40 thing. It is relevant here, but it's actually not going to be relevant quite the way that I thought. Because we also need, by the same logic, we need things that multiply to 5. So it has to be a 1 and a 5 somewhere here and here, or here and here. Because there's no other ways to make 5 besides 1 times 5. So this is my like reverse engineering way of doing it. I could be explaining it a lot better, I think, but whatever we do, we need to make sure that it adds to negative 22. So we definitely need a minus sign and a minus sign. And if we only have a 5 and a 1, let's just like try putting 1 and 5 here just to show why this doesn't work, because I don't think it will work. You get 8x squared, you get positive 5, but then when you do x times negative 5x, you get minus 5x, and we do negative 1 times 8x, you get minus 8x equals minus 13x. That's not minus 22, so those two terms don't match, so that can't be right. And this is what I'm doing in my head whenever I do problems like these. So that's why it's not always the best way, because I've done enough things where I'm going to have the mental math involved. But if you're not, I'm going to show you a different way that just will always work. And that's a quadratic formula. So we could also have a 5 here and a 1 there, because I think I did the opposite right before that. So you'll get x times negative 1 is negative x, and negative 5 times 8 is minus 40x, is minus 41x. That's also not right. So it's not this first line at all. So it has to be this line, so we can just try both combinations here. We know the 4x times x squared times 2x will work, and we know the negative 5 times negative 1 will work. So let's check 4x times negative 1, and negative 5 times 2x is negative 10x. So that's minus 14x. That's not right either. So it must be the other way around. I hope. Let's try and mess something up here. So you get 4x times minus 5x is minus 20x. Oh, hey, minus 1 times 2x is 22x. Minus 22x. So that matches up there. So I would say this is the factorization of that, and that lets us figure out what x equals. And again, I'll show a completely different way than this like kind of guess and check way. That relies a lot on like I do mental math, but you can also just like write it out like I did there too. But just to follow through, we get 4x minus 1 equals 0, and we get 2x minus 5 equals 0. So we could have x equals 1/4 from that one, and from this one we could have x equals 5/2. And if I completely lost you there, I wouldn't worry about it too much, because can you explain how that's right as of now? Okay. So sorry that I missed the exact moment when you said that, but I assume you're talking about like how we know that this part was right. That's because I engineered a situation. So I've been basically multiplying these back out every time. So I've been doing, I set these kind of like parentheses up so that when I re-multiply them out, I get to save myself a lot of work. So if you were looking at this like it's from in a vacuum and you multiplied it out, you do 4x times 2x is 8x squared. You do 4x times minus 5 is minus 20x squared. You do minus 1 times 2x is minus 2x. Oh, sorry. The last one is just x and not x squared. And that minus 1 times that minus 5 is plus 5. And so if you multiply the entire thing back out, you see it matches exactly that, and that's why we know it's right. But I engineered these so that I don't have to keep on doing the 8x squared part and the 5 part. Because I know that I did a 4x and I did a 2x, that'll always make 8x squared, and I did a negative 1 and a negative 5, that'll always make the positive 5. So I was only checking these middle two terms. So that's like why I was doing the math up there for that. I didn't bother with x times 8x because I knew that was 8x squared already. So I just said, I skipped that step and I went to x times the minus 1, and then the negative 5 times the 8x. And then I skipped over the minus 5 times the minus 1. So the way that I set these up. You get the stuff you just did? Okay. So I assume you're saying like that stuff that I just did, but I hope that helps explain a bit more of this logic. It's still, these benefit a lot from just practicing a lot of them until you get an intuitive feel, I would say. But that's kind of like my thought process when I factor a quadratic like this. What I will say is that if the numbers are nicer, let's say you had 2x squared plus 4x plus 6 equal 0. You could factor out the 2, and then you have a much easier thing to factor. If you do 2x squared plus 2x plus 3, this is a much more familiar thing for most students to factor because the 2 is like not involved anymore. So you can just focus on the inside part. So you should always look for that first before you do this whole thing. But here we can't factor the 8 out without getting fractions and things getting messy. So if you don't feel comfortable with this though, there's always the quadratic formula, which isn't the prettiest thing, but it will always work and you don't have to worry about messing up some mental math or like, you know, forgetting how exactly the trick works. And the quadratic formula, it's a bit of a beast. Like if you look it up on Google, it'll tell you like the format, but I'll just kind of like, I'll write it out. If that's A, that's B, and that's C, the quadratic formula is minus B plus or minus square root B squared minus 4AC over 2A. And just plug each of those numbers into there and you'll get the same exact answers. So B is negative 22, you can't forget the minus sign. So minus 22 plus or minus square root minus 22 squared minus 4 times 8 times 5 over 2 times A is 8, which is 16. If you simplify this down all the way, you should get these answers exactly. 22 squared, I don't have that memorized. 11 times 11 is 121, times 4 is 484. 40 times 5 is 100. Really? That's going to be a perfect square? Huh. Really? No, I need to put that into Wolfram Alpha. 384 does not seem like a perfect square. Give me 1 second. No, I messed up my math. What is 22 squared? Did I do that wrong? 44. 8 times 4 is, oh my god, that's what I messed up. Okay, I see. Fire Knight, yes. Those two are your answers, and I was just showing like a different way to, I was showing like 2 different ways to approach a problem like this, basically. So that's why I'm doing the work over here. 4 times 8 is 32, not 20. That was my problem. I think it's the problem if you do 4 times 5 is 20, 20 times 8 is 160. That will get you 324. Is that a perfect square? I don't even know. $364. Oh, is this 364 minus 4 times 8 times 5? Okay, it should be 324 according to what I got. Root 324. Oh, it's 18. Okay, good. (22) plus or minus root 324. And root 324 is 18. I forgot the over 16. Plus or minus 18 over 16. So if you take the plus, you get 40 over 16. If you take the minus, you get 4 over 16. If you simplify the fractions, they have an 8 in common, that's 5 over 2. If they have a 4 in common, that's 1 over 4. So yeah, your answer is x equals 5 over 2, comma 1/4. Either way. But yeah, whenever your a is not 1, things get tricky. Saying my way the highway. Oh gosh. I'm glad I was able to help you, Higher Knight. And Pushy, you put a problem in chat too. Dx over x squared root x squared plus 4. That seems like a hard one. What time is it? Oh god. I'll always see if I can get the idea of it, but I don't know if I'll be able to do every step of it before I'm gonna have to end stream. X squared square root x squared plus 4. Like that, I think. Yeah, that looks like what you wrote. So with a trig sub, okay, so first thing, we want to get the 4 out of town here. Actually, do we? I always mess up a trig sub when there's a 4 there. I need to look this up. Is Paul's on my notes back? Nope. I think it's gonna be a tangent. When you have a plus in the square root, you usually want tangent, I think. So I just made that mistake earlier. Okay, here we go. If we have root a squared plus x squared, we want x equals a tan theta. So we can do x equals 2 tan. Excuse me. Oh, okay, never mind. All right, so x equals 2 tan theta d theta, which means dx equals 2 secant squared theta. Oh, why did I write d theta up there? It's d theta down here. Okay. Plugging in, I'm gonna bring the dx up front. 2 secant squared theta or tan squared theta, because that's x squared, root or tan squared theta plus 4 d theta. All right. Now we want to pull that out, I guess. The 2 and the 4 can cancel to be 1/2. Tan squared theta. So the 4 can get factored out. It gets square rooted on the way out, so it becomes a 2. So actually, I'm going to multiply. So it's going to become a 1/2 and multiply that with the existing 1/2 to get 1/4. And now tangent squared plus 1 is secant squared, and the square root of secant squared is just secant. So we get secant theta d theta. So we get 1/4, cancel out the secants. Secant theta over tangent squared, which is an interesting one. How do you do that? Secant is 1 over cosine. tangent is sine over cosine. So I think we might get some cancellations if we put everything in terms of sine and cosine. So secant is 1 over cosine. So we get a cosine on the bottom. Tangent is sine over cosine. So it's sine squared theta on the bottom over cosine squared theta. I don't know if this will actually help, but maybe. 1/4 cosine theta over sine squared theta. Basically the same situation we just had, I guess. Well, actually, no, we can do, no. U equals sine theta. So du is minus, or not minus, it's positive cosine theta. There we go, that's the key. D theta, the cosine is going to cancel the cosine, and that's why this is a good sub. So you just get a 1 over u squared du. That's an integral we know how to do, which is minus 1 over u. Because it's exponent of negative 2, you add 1 to it, the negative 1 comes out front too. Yeah. Unsub again, or just unsub for the first time. U is sine theta, so 1 over sine theta. Then we have to rearrange that. Theta equals arctan x over 2. So that's equal to 1/4 times minus 1 over sine arctan x over 2. That can be simplified with a right triangle. Oh, did I mess up the trig sub? Pretty sure 1 plus tangent squared is secant squared. No, yeah, I was right with that. Okay. Sorry, I think that comment you said was from an earlier part. So arctan, let's set up a right triangle here. Theta. So tangent is opposite over adjacent, so x in 2. That, by Pythagorean theorem, the hypotenuse is x squared plus 4. So sine of this triangle is opposite over hypotenuse. And we have 1 over that, so I'll do hypotenuse over opposite, I guess. Technically plus c. Like that. I think that's our answer. Let's see if Wolfram improves. Hell yeah. Just lots of practice. Oh shit, you know, ironically, I kind of have to stall for time now, because I'd love to rate Zach doing the real analysis class, but he's not going to get started for another, like, few minutes, so... what's my other ping on Discord? Someone in the math Discord pinged me? Oh, okay. Yeah, Rishi, I'm about to end things in like 5 minutes-ish. So this person figured it out. Oh, hey, welcome into whoever joined. Wait for your exam soon. Oh, well, good luck, Rishi. Hope it goes well. See if we can find like a quick one or something in the meantime. The number of new cases per day does not exceed 5. A very long partial fractions. One second, let me check if the one that I've heard of is especially painful. Oh, no, that's not the one. No, that's not right. Okay, here, I can make a really annoying one. And I'll get Wolfram to tell me what the end result is. It's not multiplying it out for me though. 1 second. Okay. Oh my god, it's gonna make me manually type this crap. There's that. All right. A long time. So you said to be mean? So your problem, if you choose to accept it, is that I'll say there's nothing like irrational or like that out there, but it is going to be a lot of work. Oh shit. Yo, Dr. Gold, thank you so much for the raid. Welcome in everyone. Dark Aspect hate, Obama hate, Monkey hate. You caught me right as well to end stream and raid out to Zach, to be honest, but I'll always introduce myself first. I'm Don, I do math. I do math on Tuesdays, Thursdays, and Saturdays. On Wednesdays and Fridays, I do games. I'm best with calculus differential equations and below. We had another trig sub integral. Oh gosh, was it as complicated as the one that you're helping me with? Asking solve a Rubik's Cube. My best time is 17 seconds. My average is more like 25 though. Not that bad? Oh, okay, that's nice at least. Here, you know what? Just before I raid out, we can do a little solve here. Because I feel bad that like you guys just got here and I'm about to like end things, but I've been going for 5.5 hours nearly. Oh yeah, thank you for that enigma. I meant to turn the stream off sooner, and then at the end we got a couple people asking questions, so I didn't want to end things until they were fully helped. Normally my solves on stream are not that good. We're here for the Rubik's Cube. All right, so inspect it. Oh god, I got nothing out of that inspection time. I wasn't paying enough attention. Bam. Oh, hey, that was a pretty good one. 22 seconds. Normally they're a lot worse, to be honest, but you only do two sides. I mean, that's more than most people can when they're just trying to like figure it out. All right, so let me get this raid queued up here because I do need to end stream now. So I'm gonna raid out to Zach or Eats the Toy Pie, who does this real analysis class on Twitch. That's a very exciting thing that I've greatly enjoyed participating in. Sorry that you guys just got here and I'm already saying bye, but I can't take much more math. I've been making a lot of mistakes. But yeah, thanks to Dr. Gold so much for the raid. My next math day will be Thursday. That's because today's Tuesday, right? Rational root theorem. Oh gosh, well, good luck, Fishy. Yeah, hope everyone has a good day. Lover J, thank you for the follow. Yeah, I'll see you guys next time. Bye.